This training series is sponsored by Hackaholics Anonymous. To get the supporting materials for this series, like the 900-page slideshow, the 200-page notes document, and all of the pre-made shell scripts, consider joining the agent tier of Hackaholics Anonymous. You'll also get monthly Python automations, exclusive content, and direct access to me via Discord. Join Hackaholics Anonymous today.
All right, we have officially arrived to the portion of this tutorial where we're going to be going through shell scripting. And shell scripting is a very, very powerful concept, a very powerful tool. And the better you get at it, the easier your life will become in general. If you use any kind of shell, so it could be a Windows shell, a Mac OS, or a Linux. Mac OS and Linux have very similar syntaxes. So you'll essentially, if you're learning these shell scripts, you'll be very good. You'll be pretty decent at running them on Mac OS as well. Windows does have a different syntax for the most part, but there are a lot of things that are also very similar on Windows. So in general, the concept of shell scripting is just a very powerful concept for you to learn. In this particular case, we're going to be learning it for the Linux operating system using the Linux shell. And I mean, we're going to start from the very, very top. So we've already actually done this a few times throughout this tutorial, where you use the echo command to actually display something onto the screen, okay? The reason why I'm going to start here again is because now we want to embed variables into this. So if we do hello echo world, or if we do echo hello world, we can see that it's going to print it onto the screen for us. So essentially echo will print whatever this is, whatever the next piece is. It'll just print it onto the display for you unless you output it into something, right? So for example, what we did earlier was we output that into one of our text files. So if we look at any of the list of the text files that we have right here. So for example, the file.txt, if I go ahead and list that onto the screen, these were the lines that we added into this file via echo. And then the same thing, or maybe I actually did that with nano, I'm not sure, but I know for a fact that one of these things, so message.txt, or let's do cat message.txt, I know that some of these things, not exactly sure which ones they were, but we definitely did them with echo. So for the most part, I know that we can do this. So what I'm going to do is I'm just going to do a hello world, and I'm going to add this to the end of my file.txt just to display this for you, because you already saw what the contents were. So if we do this, we can now see that we have hello world at the last position of this file, because we use the double greater than symbols. If you use a single greater than symbol, it'll just overwrite the entire contents of this file, and it will only do hello world. So essentially, echo will either print it onto the screen for you, or it will output it into a different command. For example, output it into a text file, or you can pipe it into something else. That's what echo does. Now you can actually create a variable. So we can say that name equals John. And then what we're going to do is we're going to put a semicolon here, and then we're going to say echo hello, and then give the name variable to this right here by putting a dollar sign in front of it, and then you press enter and it says hello John. So that's officially our first little shell script. So we've assigned a variable, which in this case would be John, and then we're going to use the semicolon to separate to the next portion of our little script that says, hey, I want you to just say hello, John. So that's how you assign a variable. Just do the name, and this is a string variable in this particular case, because there is other ways that we can assign variables. So we can actually do name and then equal this to a dollar sign and then put a command in here. So it could be the uname command, as we already saw. And then we can say hello and then do the name, and then you'll see that it'll give us the actual name of our machine, that's what you get when you run the uname command. So you can put either a string value inside of this variable, or you can actually put an entire command's output inside of this variable and then echo that onto the screen. So just another display for you here. If we do full name, and then I will equal that to this, and then we'll go here and we'll do uname and then dash A to give us everything that's available for uname. And then we'll say something like, this is the computer's info. and then do the name at the end and then press enter. And then we can see, oh, uname-a still gives us Linux. So it actually didn't give me the full name, which is interesting because I thought uname-a would give me everything. So I guess it's stored the very first item of this particular thing, and it still give me that one item, and it was separated by a space. So instead of giving me the entire output of this whole thing, it still just gave me the first name. So there we go. I got schooled in live session right in front of you. So the point of this is that you can assign variables by just doing the whatever the name was going to be. Oh, you know what? I That's why I didn't do it right, because instead of doing echo full name, I did echo name. So if I do echo full name, that should actually work. There we go. See, okay, I feel better now. For some reason, I was like, that can't be right. I couldn't have made that mistake. But that was the mistake that I actually made. Instead of referencing the full name variable, I referenced the old variable that we had created, which is name. And that's actually a good lesson to have, is that the variables that you create in your sessions essentially stay there until you reassign something else to that. So if I reassign something now to the name of, or to the variable of name, and let's say we're reassign the Hank value to that variable, then we can say hello Hank, or not Hank, what am I saying? Hello name, and then I have replaced the old value of name, and now it says hello Hank. So it'll keep that value until you reassign the value to a different variable, or you reassign the variable to a different value. And this is our assignment operator. So when you do name with a single equal sign, you are assigning a value. So keep that in mind, because we're going to get into comparative operators, which means when you do two equal signs, now you're asking the system, does name actually equal Hank? If the name equals Hank, then I want you to do something, right? So the assignment is when you do a single equal sign and you say, I want the value of this variable to equal this value. And then when you do the double equal signs, you're checking, does the value of this variable equal to this particular value? So that's what we have so far with echo, and then assigning variables here. So now what we can do is we can prompt a new line on our screen that says, I want you to do something, and then that you're asking the user that is reading this to go ahead and give you some information here. Okay. So for example, it would be echo n for new line, and then we're going to say enter your name. Okay. And then we're giving them this, and then it says, okay, enter your name. So this is the new line that we are entering. And now we're going to read the output of that, right? So the reading of the output would be something that can be stored inside of the variable that we have. So this would be prompting, just we're literally just echoing the new line. So this isn't going to take anything here. If we do read of the prompt, so if we do read the prompt and then we go enter your name again and give it a space, and then we're going to assign this to the name variable, press enter, and no, okay, so let me actually make sure I'm doing this right. So let me see 1 second. Okay, so I actually had to verify. I don't believe, or at least based on the education that I have received, that we can actually do this interactively within the shell. I'm going to try to do this one more time interactively within the shell, and if it works, great. If it doesn't, then we're going to actually write our very first shell script, and then we're just going to run the script. So if we do echo one more time, and the echo command is going to request a new line to be entered. So it would be, or no new line after this. So it would be enter your name would be the prompt, and I would say that. And if I say Hank, and okay, so that's not going to work. So now we actually have to create our very first shell script, and I don't have anything on this desktop that is a .csh file. So now we can actually go and create our very first shell script, and we'll just call it intro.sh. When you're creating a shell script, you need to add something to the top of it called the shebang line. The shebang line is going to use this section as the interpreter. So let's say you want bash to be your interpreter, which is a version of the shell syntax. If you want bash to be your interpreter, you would give it the location of your bin bash. And actually, I'm going to exit out of this real quick, and I'm going to check for my individual user. So if I go to cat of the etc password file, it'll show me what my individual user's bash is, and for me, it's actually user bin zh. That would be my individual's shell, right? So we can now go back to nano intro.sh, and we will do shebang, and then we will do user bin ZSH. I believe that's what it was. Hopefully that's what it was. So that's my shebang line. That's basically saying that the rest of the contents of this document are a shell script. And so you need to read this document as a shell script and use this specific shell as my interpreter to interpret the commands that I'm giving you and then process them as if they are a script. So your very first line on every shell script needs to be the location of the shell interpreter that you're going to use. A lot of times it is actually bin bash, and I'm pretty sure that I actually even do have a binary bash. So we'll just save this one in this particular case so that we can come back to it. So if I go to and list the contents of the binaries, we should see there should be a bash in here at the very, very top under B. So these are all of our binaries inside of the system. So let's go look at these very quickly at the very, very top. Look at how many freaking binaries are inside of Linux. How crazy is this? This is typically what it's like inside of any computer, by the way. There's so many binaries that are just running and available that you don't even know. And a lot of times we just say, yeah, I just want to use a calculator or whatever. So there we go. There is actually a bash binary in here as well. So I can actually use that if I wanted to, or I can use the binary for my actual user, which is the user bin zsh. So we'll do the systems binary, so bin bash, that'll be our interpreter. And then we can start actually writing our command. So the first one is going to be echo on no new line, which is going to be enter your name. And then that's going to be what's going to be printed onto the screen, which is going to be the command that has been given or the prompt that has been given to the user. Once the user gets that prompt, we're going to then read the response of that prompt. So we're going to read what they actually type, and then we're going to store it inside of the name variable. And then we can say echo and hello, and now give the name variable into it, right? So now we are actually using that name variable. So echo, hello, name, and then now we have given our first official kind of interaction with our script. The first one is saying echo, enter your name. Then it says reading of the name, and then it stores it inside of the name variable. And then we feed it back to the person by saying hello, Alex, or whatever. The next one, to kind of repeat this process, would be echo enter your age. And this n that we're using here means that we don't want a new line to be entered after the fact. So we just want this to stand alone as it is. And then after this, the very next thing would be read by the system. So now we are reading the input of the user and we're storing it inside of the age value. And then we're going to feed that back to the user. And we're going to say, you are age years old, right? That's the interaction that we have. So we're going to say, enter your age. We're going to input an age. You are this many years old. Okay. And then finally, we can go ahead and combine some of these things with another command that is actually going to store a password, for example. If we wanted to store a password and we wanted to prompt the user to give us a password. So you can do something like enter your password. So you can do read, in this case, secretly, and then we're going to give a prompt. So we're going to say read this prompt and enter your password. And what's going to happen is that the person using or responding to this particular prompt, they're not going to be able to see their input onto the screen. So when I actually do this, I shouldn't be able to see what I'm typing when I write out my actual password, okay? And then once that's done, we're going to just echo back something to the screen saying that the password has been accepted and you're all good. we will do an echo, and then we'll do another echo command to say the password has been accepted. And that's essentially the workflow that we have here. So boom, press Control O that you want to write it. You press enter that you're confirming that. We're going to exit out. And now let's actually try to run this intro.sh file. And it says permission denied. So let me make it executable, because most likely I do need to make it executable for that. So it'll be intro.sh is now executable. So let's try to run it again. And it says enter your name. So my name is Hank. It says hello, Hank. Enter your age. My name is 38. You are 38 years old. And now you can see that it says enter your password, and password. There you go. So when I type that, it didn't print that onto the screen, because we want to keep that quiet, right? We want to keep that secret. So if somebody's over, watching your screen over your shoulder, they shouldn't be able to see you entering your password. So this is the most basic shell script that we've created so far. It's just a combination of echo commands or echo prompts saying, hey, enter your such and such. And then when somebody feeds their response to this, and then you can see that instead of giving me a new line, so let's run that one more time, right? Intro.sh. So it says enter your name. And instead of giving me a new line to type it on, so me printing down here, I'm actually typing right next to the end of this prompt. That's what that -n does. It doesn't create a new line. We just go ahead and type it at the very end of this line. So we'll do Bill in this case. It says, hey, Bill, enter your age. Bill is 40. Hey, you are 40 years old, enter your password, and then we're going to type in password. And that's basically it, right? That's the most common, not most common, but like the simplest version of a script that we can create. And it's a combination of essentially echo commands that will be read with the read command. And then once you read the response that the person has given, it gets stored inside of a variable. For this one is the variable name. For this one is the variable age. And then we just feed it back onto the screen with another echo command. So we echo this, the response of the person ends up being hello, and you store that. And I'm sorry, the response isn't hello. The response is read. So whatever we type over here will be read by the system. And so let's actually just go and look at our script to kind of break it down even easier. So we go into it and we can see, all right, so the first one, this is a prompt that the user is getting. The response of this will be read, and then it's going to be stored inside of the name variable, and then we're going to print that back to the user. The next one will be enter your age, and the response for that will be read, and it will be stored inside of the age variable, and then it's going to be printed back to the user. And then finally, we can actually read the response of somebody's prompt input. We can read that by just doing the read command and then giving the prompt, right? So if I remove this S, it would still give the prompt, and it would say enter your password, and it would still store that value inside of this password variable. So you can kind of shortcut this process right here by just saying read and then give a prompt and then enter your password. And then because of the fact that it starts with a read, it's expecting that there's going to be some kind of a response to this. And that response is going to be stored inside of this variable. And then we're going to echo that back, and we're going to say, okay, password has been accepted, or whatever. If they don't type something that you don't want to type. So for example, let's say your rules for your password are it's only alphanumeric, you can't put any special characters. And if they put a special character, we can say if the password variable, and I'm getting ahead of myself, so we'll do this in an actual script, but we'll say if the password variable includes non-alphanumeric or is not alphanumeric, then I need you to print that this is incorrect password. You need to only use letters and numbers. And then if it is alphanumeric, then you can print and say password has been accepted. So this is our very first, very basic shell script that we just created. For loops is where the automation power of scripting really starts to kick in. And loops in general is when the automative, or automation power of scripting really starts to take over. And then you start noticing, okay, wow, this can actually be a very, very useful tool here. A for loop is also known as an iterative statement. So it iterates through a list of items that you tell it to iterate through. And then for every item in that list, it's going to do something. So we're going to create another file here. So we have our basic shell. Where is it? So we have the intro.sh. So now we're going to work essentially with the same second shell file, and we call it the loop. We'll call it the loop.sh file. And we're going to open this up. Again, at the very top, we need to put a shebang line for us, which is going to be the bin bash, which is the interpreter for this particular shell. And essentially, for every shell that you create, every shell script that you create, you need to put the shebang line at the very top. So this is my current iterative statement in this particular case. So this is just an example here. Number one, we need to make sure that there is a, we call it a tab. So I think a full tab right here should actually be probably, I think it should be fine. And actually, I misplaced it. So the do needs to be at the end of the first line, which we call the header. And then the commands would be inside of the body. And we'll place those here. And essentially, this is what it's going to look like, right? So this is what the loop entirety would look like. So you would have 4 item in this list. I want you to do command 1, command 2, whatever the rest of the commands are. And then when you're done with this, you need to put done, and then the loop will end and everything will be all good. So in order for the for loop to actually process properly, there needs to be a done at the very end of it. And notice that it's on the same line, the same indentation that the original for loop is in. So if I actually indented this and then indented these two, because this was a part of another for loop, because you can actually do this as well. So it goes, we can actually have multiple for loops for item in list, do this. So we can have a for loop inside of a for loop. And so if that's indeed the case, then the done for this for loop needs to be on that indentation, and then the done for the first for loop needs to be on this indentation. So you can, it's essentially store any type of loop inside of another one, and you can combine these strategies as we start building more complex scripts here. But this is the basic structure of a iterative loop, a for loop. So it says for item in this list, I want you to do something. And we're going to demonstrate this in a multiple variety of ways right now, just so you can really see how powerful this can be. So the most simple version of it, and this was the version that I was taught first, which is the easiest to understand, is to just go through a list of numbers or go through a list of strings or something like that and just print it onto the screen. Okay, that's basically it. So go through a list of numbers and then just print those numbers onto the screen. That's what our very first for loop is going to end up doing. And the way that looks is that it's going to be for I. So the very first variable that you see right here, this could literally be anything. For it could be for n, it could be for I, it could be for x. Doesn't really matter. This part does not matter. And in a lot of cases, I've actually seen people even use the underscore as the variable that is the variable that's going to go through the list, right? So if I say for I in, and then we do these little squiggly brackets, implying that we're going to create a list of something. And then when you say 1.5, it's going to say 1 through 5. Okay, so when you do for I in 1.5, and this typically only works with numbers because the system can tell that, okay, there is 1, 2, 3, 4, and 5. So it can say 1 to 5, and it can actually do that. You can't really do that with string values. So if you have a list that's storing a bunch of different strings, or a list that's storing other lists inside of it, it's going to be a little bit, maybe in that case, I think it would actually work. You just need to use different qualifiers to say that I'm not asking you to iterate through a list of numbers. I'm asking you to iterate through this particular list from the first position to the fifth position, but then we would need to use a different qualifier, and I'm kind of getting ahead of myself, so I apologize for that, but it can technically work for iterating through a list of items, so long as we have the qualifier that says these are actually items. So each one of these things that's separated by a comma, for example, is its own item. So if you have a list of 10 items, then iterating through the first through the fifth position of that list will print the first through the fifth position of those items. Okay. But right now we're just dealing with numbers. Sorry for making it overly complicated. I tend to do that because I want to over explain things sometimes. So it's kind of makes me go crazy. So for I in 1 through 5, we are going to echo number and then do the number and then the variable, which is I in that particular case. And that's it. It's just going to print it onto the screen and then we're going to be done. And that's it. That's our entire shell. We're going to quit that. I'm curious whether or not if I just press tab, which I just did right now, the loop will actually still work. So obviously we need to make sure that we give the loop the permission to execute. So I'm just going to do loop.sh and change the permissions for it. And then from here we go. Fingers crossed. There we go. It actually works. So perfect. That actually makes it super, super easy. This is one of the big things that I'm very big on for the most recent version of Nano is that you can actually press tab and it'll indent for you. And then the script will be perfectly fine and it'll work exactly the way that it's supposed to. So that was it. That was like the very first for loop. So I hope you're actually creating these things line by line as I'm doing them as well. So you can understand how to kind of get these things into your fingertips so that you really, really learn how to create these scripts well. So we're going to go back into our loop shell and we can see very, very simple script, right? So for this variable inside of this list, I want you to iterate through this list. So if I just change this right here and then save this, and then we'll go out and then we'll run that one more time, you'll see that it'll iterate through all the way to 10. And you can change this for however many that you want. And you can essentially replace numbers with strings. You can replace numbers with counting through the characters, iterating through the characters of something, or you can replace numbers with the items on a list. So for loops are very, very functional, and they can even iterate through individual documents or individual commands that you want to run. So for this one, it was just to echo something. The command was echo this onto the screen, print it onto the screen. But I could actually say, parse this log file or condense and zip this log file for me or display the contents of a text file. That's probably a really good one because we have multiple text files on our screen over here. So we can actually display the contents of these text files by using our little for loop here. So let's go ahead and actually do that. All right, so we're going to go back inside of our shell file here. And now we're going to create a completely separate loop. So in this particular case, what we're going to do is, again, I could also do for I, but just to make it a little bit more user friendly, we're going to create a new variable, which is going to say file. And for file in, and then we're going to do an asterisk to be a wildcard character, txt. So essentially it's going to look inside of my current location. So if I wanted to look inside a different location, I would have to give it the full path of the location, for example, something like that. But when I just do asterisk.txt, it's going to look inside of the current path that I'm on, inside of my current directory. So for file in anything that ends with a txt, that's what we're doing here. I want you to do this. And the first thing is we're going to say echo, and then we're going to say reading file. Okay. That's going to be the first thing that's going to print onto the screen. And then we'll do a little thing to make it kind of visually pleasing. So we'll just echo a bunch of lines onto the screen like that to kind of be a separator. And then we're going to cat the file, right? So cat file, that's what it's going to do. It's going to just print the contents of that file onto my screen. And then we're going to do another echo where I should have probably just copied this, but we're going to do another little separator line. And then from here, it should reiterate through this entire series of commands, and we'll just do done here. It's going to reiterate through this entire series of commands, and then it's going to find the next text file, and it's going to say it's reading that file, and then it's going to echo. And actually, to make it even nicer, we can do this, right? I can go here, and I can do another line right here. Now I'm just getting dorky with this, so forgive me. But now I have like this little thing. It's gonna read the file and then it's gonna separate it and it's gonna do the next one and the next one and the next one. It's just gonna print all of the contents of those files onto our screen for us. So now we've combined the reading of text documents. So we're sorting through a list of text documents inside of our current directory, and we're going to read the actual text documents onto the screen. So we're going to say cat and concatenate the contents of those files onto my screen. And then for each one, it's just going to say, I'm reading this file name. So it'll read the actual file name and I'll say, this is what I'm going to read onto the screen for you. And it's going to read it and it's going to print it onto the screen. And hopefully I have not made any mistakes here. So we will now run the loop.sh. Look at that. So, there we go. So now we have our little error here. So it says it's actually reading the doc, so that's fine. But the reading of the file is for whatever reason not working. So it's not able to read the doc.txt or file.txt, which is actually so interesting because I know for a fact that it does exist. So I do have a cat file.txt. So I wonder why it's not able to read the contents of it or notice the contents of that file. So let's run that one more time and let's do a little bit of troubleshooting here. This was the most rookie mistake that anybody can make, so please learn from my mistake. Do not make my mistake. You have to refer to the variable as a variable. This is very, very important. I'm so used to writing code in Python that I just forgot that I had to add the dollar sign in front of this variable if I want to refer to that variable. In Python, you don't have to do that. In Python, you just type in the actual variable itself, and the syntax of the language will process it for you as such. And shell is a little bit different. So you actually have to refer to every single variable that you want to refer to by putting that dollar sign in front of it. So that is the big mistake that I made because I'm so used to Python. And again, my apologies for that. So that is the only edit that we needed to make for this. And we're going to now save it. And then we're going to run it one more time. And this time around, I am fairly certain that it's going to work. Okay, and it did. And now we have a massive amount of outputs that's available here. So we can see that our files are actually being read by our script. So it's very, very cool little script that we have. Okay, so moving on to our next script here. Let's see if we can now run a little bit more of a complex command. So we ran through the file, we read through the file, and now we are going to try to do something a little bit more sophisticated with our for loop. All right, so I'm going to display all the files in here. So you can see that we have I think, what is it? We have 6 text files that are existing on my desktop right now. And let's say I want to compress all of these things, right? So this is another one of those things that becomes very, very useful. So we had just finished going through the archiving commands and the compression commands and everything. So, excuse me. So now we're going to compress all of these files by creating a nice little script that will actually do it for us. So this doesn't change much with the exception of the actual functionality of the script that we're doing. So now here, instead of saying it's reading the file, number one, it's just going to press type out for us that is compressing the file. And then instead of cat of the file, what we're going to do is we're just going to say gzip, and then that's it. That's the entire command change. But now the functionality of this script has completely changed for us. And so what it's going to do is it's now going to zip that file. And I like gzip because instead of creating an archive and then leaving the original file, if I just do gzip and then the command name or the file name, what it's going to do is it's going to create that file for me, the archived file for me, and then it's going to just take the place of the previous file. So the desktop isn't going to get polluted, essentially. It's just going to compress it, and then we're now going to see a different display of the files that we have on our screen. So that's basically it. Gzip file, and we're done. We're going to exit out of this. So as you can see, the files look like this, right? So they're white and they end with .txt. That is the current setup of that. So now I'm going to go loop.sh, run that, and it's compressing everything. I could have probably just removed all of these extra lines, but whatever. Now it seems a little bit redundant now because I don't need that many separators here. So now we've done that. We can go here in ls, and now we can see that all of our uh, lines here, all of our documents have actually been turned into zip files. Okay, so that's actually very, very useful. So imagine having to compress a bunch of log files, for example, or compressing a bunch of files that you know for a fact that it's just going to take a long time. It's important to do, but you don't want to manually sit there and do them. It's as easy as literally writing a script that is this simple. This is such a simple script. When you really, really think about it, it is not that complicated to do what I just did inside of this script. Very, very simple script. So what I'm going to do is I'm just going to remove these extra lines because it kind of just seems a little bit redundant here. We'll leave one line, but then that's it. That's it. It's going to compress the file and it's going to move on to the next one. It's going to compress another one. So now that I've done this, what I want to do is I want to unzip these. So we'll do G unzip, or we're going to do gunzip. I just like calling it gunzip. And then same thing. We're going to save it, press enter, go out, and then run the loop. And it is no such file or directory. Oh, whoops. You know what? I actually have to give it the proper extension now. So I didn't give it the updated extension. The extension now is the .gz is actually at the end of those files. So now we need to actually update our variable up here. And instead of saying .txt and leaving it, it's going to be .txt.gz, and that is going to be what it's going to look for. And now when we run it, it is going to uh, it's supposed to say decompressing. I forgot to change the message. I'm just so excited to run these scripts, but we can just run ls and we can see that all of the files have been decompressed. So I needed to update the message on the screen, but for the most part, it did what it was supposed to do, right? So it actually did decompress all of those files, so they're no longer read, obviously, and they're no longer ending with the .gz at the end of them, implying that they're zip files. They are now back to their original state, which means they are now text files. So very, very simple script, but a very powerful script because you are most likely going to compress a bunch of things over and over and over again. And really the concept here is that you can basically put any command inside of this. So any command line command you can put inside of this. And as long as you have a good qualifier, a good identifier at the top of your loop, this is the header of the loop and this is the body of the loop. So in the header of your loop, as long as you have a really good identifier and you know what you're looking for inside of that particular directory, for example, then it's just going to run the command that it's supposed to run quickly, easily, efficient, like in a fraction of it's not even a full second. It took a fraction of a second and it did everything that I wanted to do. And if I was going to manually zip all of those things, even if I did this, right? So even if I went up and then press enter and just repeated the last thing, the last command, I would still need to go over here and edit the name of the file and do all of that extra stuff when I could literally just write a loop that will iterate through it for me and just find everything by the extension of it and do the job that it's supposed to do. So it's a very, very powerful concept to just use a for loop to iterate through something when you need to run repeated tasks. So we'll do one or two more examples and then we're going to move on to the next type of loop, which is going to be the while loop. So let's do a couple more examples here. The updates now we're going to do, so let's say we're going to go and run through all of the directories that are in any given location. So in this particular case, I can change this and I can say for all of the directories inside of the home Kali user, okay? For all the directories inside of the home Kali user, and then I'll have to do one more forward slash and an asterisk to imply that basically anything that comes after this, I want you to run a specific command for me. So in this case, the output of this is going to be massive. So I do understand that this is going to be a really, really busy screen here. But so in this case, I don't need to echo anything because it's just going to run the command. And for example, the command itself would be the disk usage command. So DU stands for disk usage. We've gone through this in the lecture as well as earlier on in this training series on the command line. When you do disk usage, you basically just do it like a, let's say the human readable. So it's the summary and the human readable format of the summary. And then you want to give it the variable, which will be the dir. So it's going to say for all of the directories, for all of the folders inside of this location. So anything that you find, that's what that asterisk represents. Anything that you find inside of this location, I want you to run dush, which means the summary version and the human readable version, and then just give me what is going on with that directory and how much disk space it's actually using, so on and so forth, right? So we're just going to run it like that. Very, very easy. And that's it for the script. Again, simple script, but it's a very functional script. So we're going to go ahead and run it. And there we go. So this is the summary version. So we have the home Kali desktop folder that's currently using up 36 kilobytes, massive. We have the documents folder downloads, all these guys. There's nothing in there because I haven't done anything with them. And then there's the Zoom, the download file that I had that it's still on my desktop. So this is the Debian down installation file for Zoom, and that's still there, and that's taking up 200 megabytes of space. And that's pretty much it. That's as like literally as simple as I can make a script for you, but you can see how functional this freaking thing can be, right? So we can do this in even a, let's say, a much bigger location, right? So let's go and look at the loop.sh, and then instead of just limiting it to the Kali user, which I mean, there's no other user that's available on this computer right now. So we're just going to look at everything on the home directory and then run the command on there and give us a summary in human readable format. So we're going to do that. And then we're just going to do dot, which representing our current directory / and then give it the name of the shell file. And that's it. That's all you need to do to run a shell file. And it says home bill permission denied because we actually still have Bill's freaking directory that I forgot to delete. So, but it does say that the Kali user is using 801 megabytes in total. The Bill user is not using anything because it's empty and I forgot to delete the guy's freaking home directory. So while we're here, why not just go and delete his home directory? So let's go to home here and we see there's Bill. So we're going to remove recursively, and I need to do sudo. So we're going to sudo remove recursively everything for Bill as well as Bill, and Bill is gone. He's out of here. So now we are good, and we can go back to our original location, which is our desktop. And so let's go into the desktop, and there are the files that we're working with. So you can see again how simple this can be, but how powerful it is. It's literally 3 lines of code. Like, really, when you think about it, this particular script, with the exception of the actual shebang at the top, which is technically a piece of code as well, there's literally just 3 lines of code that are inside of this thing, which is, I mean, I don't know how else to drive home the point that this can be so powerful yet so simple. So I'm gonna do one more example for you, and then with that example, we'll move on to the next type of loop, and hopefully you'll really, really kind of get a kick out of these things. And I hope that you can see all of the different ways that you can take advantage of this approach and make your life so much easier. So let's get out of here and let's do, actually, I do need to be back in here. So let's do another loop and we'll wrap it up for loops. This example is just to show you how to iterate through a for name in, let's say, Hank, Mesh, Jill, Bill, whatever. It'll iterate through a list of strings in this particular case. Each one of these guys is represented as its own item and is separated by a space, and it could be anything, right? So this, in this case, it's just going to be names, but essentially it could be anything that you can feed to this piece, and we're going to just say echo this. So we're just going back to the echo. So name is, and then we'll use the $ name and close that out, and then we're done. And that's it. So very, very simple script. Again, it's just now just trying to demonstrate that you can iterate through names instead of just numbers or obviously the commands that we ran. So this should have probably been like one of the first ones because it's one of the simpler ones. I just wanted to demonstrate that you can iterate through strings. Technically, these are called string values, and you can iterate through string values the same way that you would have iterated through the number values. It's just simpler because you don't have to put them inside of these little squigglies right here, and then you would just do the echo, or you would do anything. Like you can combine any of the other commands that are available on the bash processing language. Really, you can use that entire syntax, everything that's available, to do anything, any type of manipulation that you want to strings, including print them onto your screen. So that's basically it. That was the last thing that I had for you for a for loop, to keep it simple, because I just want to show you what for loops can do. And then, of course, as we get to the section where we're going to start creating official scripts that you're going to end up using to do system administration and to automate a lot of your tasks, when we get to that point, you will see how all of these things combine and just how powerful they actually can be. So that was it for loops. So let's move on to while loops. Okay, so let's talk about while loops. And while loops are another part of the control structures inside of shell scripting. And while loops essentially deal with one condition, and the condition is whether or not something is true. So, for example, it would say, while this is true, I want you to do this. And as soon as it's false, stop doing it, right? And they can actually be permanent. So if you never give it the condition of when something goes false, it will constantly keep running. So while loops are literally permanent statements unless you give them some kind of a false condition where at some point it'll break the loop. And so here's what I mean by that. So let's actually go back into our nano loop file here, and let's modify it to create this very first while loop. Now, in this particular case, I'm just going to say while, it needs to be correct here. So we're going to say while the count variable is less than 5, then I want you to do this, where you just echo count, and then we'll give it the count variable. And then in this particular case, we're going to close that off. And then that's pretty much it, right? So while count is less than 5, I want you to echo the count and then just keep going. And then we're going to say done, and that would be the end of this version of the script. And then at the very top, now we just need to create a count variable, which is going to be equals to 1, right? So obviously, 1 is less than 5, and it's going to stay less than 5. And there are no other conditions, or there are no other actions that are being taken on this. So what's going to happen in this case is that this script is just going to keep running, and it's going to just keep printing count indefinitely. And then it's literally going to keep running. Like if I don't stop this, it'll just keep printing count, 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 count. So I have to stop it manually. Okay. Otherwise it will literally keep running, and it'll just take up processing power over and over. And ultimately it'll just kind of make the system crash, because all it's doing is just printing count. Like I'm still scrolling up and this is still going, because all it did over and over and over again was keep typing the count 1 onto my screen. So in order to stop that from taking place, we need to give it a second condition, essentially, or we need to give it a second command to actually change this whole process. So what's going to happen is that we need to give it I'm actually going to try a few different versions of this. So the first one, I'm just going to add. So I'm going to iterate, and I'm going to add to the count, we're just going to say plus 1. So we're going to increment, or instead of iterating, we're going to increment the count variable by 1 on each one of these runs. And so when it gets to 4, it should technically stop, because we were saying as long as it's less than 5, keep going. And then when it gets to 5, it should stop, right? So we're going to save this right here, close that out, and then we're going to run the loop, and there you go. So when it gets to 4, it'll stop, because now 4 is less than 5, and then from there the condition becomes false, right? So going back into the loop right here, the first iteration of this count is 1, so it's true. While count is less than 5, that is actually true, so we're going to echo count. But then after that first iteration, we're going to increment by 1, meaning now on the second iteration, it's going to be 2. So then it's going to check this and it's going to say, oh, okay, it's still less than 5, yes. And then so it's going to echo the count for us. And then it'll increment another one. So on the third one, it'll be 3. And yes, that's still less than 5, increment by 1. On the fourth one, it'll be 4. And yes, that's still less than 5, increment by 1. On the fifth one, it'll be 5. So 5 is no longer less than 5, it's equal to 5. So at that point, it becomes false. It's no longer a true statement. So the loop will break. Now, if I wanted to make it so that it went all the way to 5, we would change our comparative operator here to less than or equal to. Instead of saying less than, we would say less than or equal to. And now when we actually run this, it'll loop all the way to the number 5 because 5 is equal to 5. So it'll go 1, 2, 3, 4, 5. Okay, we're at equal. And then when on the next iteration, it's going to be 6. So 6 is no longer less than and it's no longer equal to 5. So it'll stop running. And this is the most basic version of creating a while loop here. So we can essentially now change this and turn it into anything, right? I could turn this into 10 and then save this thing here and then just loop and run that, and now it'll count to 10 because it's going to go all the way up to 10. When it hits 10, okay, we're equal to 10. 11 is greater than 10, and now it's going to break and it's no longer true. It's a false condition, and at that point, it doesn't work anymore. So the while loop is fairly simple, but it's very powerful. And in this particular case, we're dealing with integers and we're incrementing the integer by 1 every single time that it runs, and then until it gets to that 10, it'll stop running. You can also do this with other types of conditions where you can say where the value of a certain variable, and it would be a string value, or it could be a list value, or it could be the number of items inside of a list, or it could be while a page is loaded, for example, or while a document exists. So if, document or a log file, for example, while a certain log file exists, then continue performing this operation. If the log file is deleted, then your operation will no longer be continued. While an employee is still in our system, continue running this operation while this employee, as soon as this employee is fired or they quit, they're no longer in our system, then stop running the operation. So the while loop is very useful in a lot of different environments, very similar to the for loop. And they're both very useful in the control constructs. And what we can do with these is even combine them, right? So if we say while this is the case right here, I can go inside of my loop here and I could say for I in list, whatever, do something else. And then we would, of course, need to indent these so that the indentation is running properly. And then there's the done that's available for the for loop, and then there needs to be a done that's available for the while loop. So you can also combine the instances of different types of loops inside of the inside of each other. So I could actually even do it the opposite way, where I have for item in list do, and then have a while condition is true do, and then have condition or command, right? And another command. And then now I will do done here, and then I'll do done here. So technically I can reverse the order where I have a while loop inside of a for loop. I can have a for loop inside of a while loop. I can have multiple while loops inside of a for loop. I can have a for loop, and then there's a while loop inside of it. And then inside of this while loop, I can have another for loop, and then that'll be like this, and that'll run like this. And then we will go ahead and move this over here, and we will go ahead and move this over here, and then we'll have another done condition. So you can essentially combine this infinitely. It will get, fairly complicated after a while. So you do want to tread softly when you start combining these various conditions and these various command control statements, so to speak. But that was the very first iteration that we did, or the first example that we did for the while loop. So let's try to find another example that would be useful that will hopefully drive this point home. In this particular situation, what we're going to do is we're going to use our read command that we had earlier, and we're going to create a new little command that is reading the lines of a given document. And we're combining the while loop with a new command, which is the input.txt with this less than symbol. So what's going to happen is that right after the done structure, we are taking the contents of this input.txt file. So for me, I will say, I forget what I had on the thing. So I have to actually just real quick verify which one of our files had the various names in it. So there were the files, the message sort. I think it was the sort file, or maybe even the file document itself. So okay, that's fine. So that's a short enough document. So we can use the file document for that specific example. So it will iterate through every single one of those lines, and it will just say red line, and then it'll say that's the line that it read, right? Basically, that's it. So while you are reading the line, go ahead and echo these lines, and then you're going to read essentially every line inside of this file and then just print it onto the screen for me. And then when you run out of lines, you're gonna stop operating. So while there are lines to read, that's basically the condition. While reading line is true, meaning while there are lines to read, you will go ahead and read those lines, and then you're going to print this screen, this item for me, or this, excuse me, this message for me, and then you're going to actually print the value of that line for me, and then from there, whenever you're out of lines, you just stop running, and that's it. That's the iterative or the while loop kind of while true version of this thing. So we're going to do that. And so now it's reading each one of those lines for us, and it's going to say, this is a line, this is another one, another one. And then finally, the last line that we added to it at the beginning of this when we were echoing into it. And that's it. That's essentially combining a few different tools that we've covered so far. So we have the read command that we did when we were creating the input and then the reading of somebody's input. And now we're actually using that read command to read the various lines of a given text document. And then in this particular case, I can just go ahead and iterate over this, and I can essentially change this to any of our other files, and it'll still do the same exact thing, right? So, I mean, this is the reusability that we were talking about when it was and sort.txt. I think in this case is actually processing sort as a command. So maybe I need to put this inside of a sort.txt like this. Maybe that'll be, hopefully I think that'll work, because I think sort by itself is actually a command. So it may not work because the sort command, oh no, it did work. Okay, very good. If I did not put it inside of the quotations, then it would actually try to sort everything, and then that ends up being a little pain in the butt. But so it's actually, it did read it. It has not sorted it, because we can see that Nathan obviously is later than document. So N is later than D, and L is later than A. So it hasn't actually sorted it, which is what the sort command would end up doing. All it's doing is just printing the contents of that sort text file onto our screen for us. So that's essentially what we can do when we combine the read command with the input being reversed into our file at the end right here. So when you see this backward thing, that means that the contents of this are now being fed into this entire loop right here. The contents of this file are being fed into this whole loop. So that's what this symbol right here represents. And it's actually fairly simple. Like when you understand that this is how you can feed the contents of a file into a while loop, it ends up becoming, again, a 3-line code. And now this 3-line code is actually achieving a pretty useful functionality, assuming that you want to read something and then distribute the lines onto the screen the way that you are, and you wouldn't want to just concatenate it onto the screen using the cat command. So that is the example that we have while reading this specific file. Now, this particular loop that we're going to create right now, it's actually going to be much more useful, and this is how you can check for the inclusion or for the existence of any given item inside of a file or a directory. So let's say we want to check the file for the folder temp done. Okay, so the file itself is going to be called the done file, and it's going to be inside of our condition here where we say while not. So that's what the exclamation represents. It's saying as long as this file, which is this right here, this done file inside of my temp folder, as long as that file does not exist, I want you to do this piece. And then when the file is created, then you're going to do something else. So it's going to do echo and it's going to say waiting for the file to be created. Okay. And then we'll just put that over here and then we're going to do sleep and then we'll do, let's say 2 seconds of sleep. And then from here, it's going to be done. And then when that is actually completed, then it's going to say file has been created, right? So now it's waiting for that file to be created. So long as that file is not created, this is just going to wait every 2 seconds and say waiting for the file to be created, waiting for the file to be created, waiting for it to be created. And it's just going to keep doing that every 2 seconds until I create that actual file. So just to make this less noisy, we'll do 3 seconds wait. So it's going to keep doing that until I create the actual file. So that's basically the script that we have ran on this particular environment, right? So that's it. That's the entirety of the script. But what it's doing is that it's actually checking for the existence of something. So while this does not exist, this is the portion where it says not. So while not file on temp done, that's kind of the breakdown of this. So what this portion is saying is that as long as this file does not exist, then I want you to do this. And then once the file has been created, so when this condition now becomes false, meaning the file does exist, right? So if it doesn't exist, keep doing this. If it does exist, then stop running and then print for me that the file has been created. That's what we're doing. So we're going to do that. We're going to loop sh and it's going to say waiting for the file to be created, waiting 3 seconds, waiting for the file to be created, waiting 3 seconds, waiting for the file to be created. So now I'm going to open up not a browser. We'll actually open up another terminal. And inside of this terminal, what we're going to do is we're going to create that file. So we're going to kind of put this over here. And we're going to zoom this in for you just so you can see what I'm doing. And basically what I'm going to do is touch. And inside of the temp folder, I'm going to create a done file. Press enter. Look at that. The file was created. And now we got the message on our screen over here that said the file is created. And it was instantaneous, you see? So as soon as it just kept iterating and it said, hey, I'm waiting for this, I'm waiting for this, I'm waiting for this. And then boom, okay, the file has been created now. And then the loop ended and we accomplished the end of our script. So this is actually very, very useful. Believe it or not, there are a lot of different implementations that you can have for this specific logic that you have over here. You can check for the existence of something, and it could be the existence of anything, right? So I could even just leave an asterisk on this particular place, and I can say, as long as this specific location is empty, I want you to say, or I want you to do something. But if anything is placed inside of this location, now I need you to notify me and let me know what's going on inside of that location. So that is what is available for this specific logic iteration of the while loop that we have on here. So let's go and create another one that's a little bit more advanced than this one. Now, this is something that you can create an interactive loop for. So if we actually give it a condition in this case where it's going to say, while the variable for choice, okay, is not equal to Q, the actual letter Q, then I want you to, whoops, let me make sure that I write this correctly. I want you to do the following. Number one, I want you to echo that I want the person to select an option, okay? Then you're going to echo the actual options that they can have. So for example, one is going to be say hello. Two is going to be say or show date. Let's just keep it with the actual notes that we have there. And then the third one is going to be Q, which means quit. So these are going to be the particular options that the user can choose from. And now that these options are available, we need to read the person's choice, right? So the user is going to be interacting with this. So after they've selected their choice, we need to actually read their choice. and then it's going to say enter your choice, right? And we're going to store that inside of this choice variable here. So choice right now is empty. There's no choice being made. We've added a choice variable that is going to be a part of our statement, our condition here. And then we're going to read the value of this prompt that's going to be stored inside of the choice variable. Now, there's something called case, meaning in case the choice in these things is this. So in case the choice is one, right? In case the choice is one, I want you to echo hello world because they said say hello, right? In case the choice is number two, I want you to just print the date. In case the choice is three, I want you to say goodbye because that's our choice number, which is for quit essentially. So it's not good Google. You're going to say goodbye. And then you're going to actually have an invalid option as well, which is the number four technically. And you would say echo invalid option. Okay. And that's it. So we have these conditions that we have over here, and I forgot to put these double semicolons at the end of this. So that's basically what this is going to look like, right? So it's going to actually print this, and I need to also put this inside of that. So that's what it's going to look like over here. So there you go. Now it's complete. So we actually have the first few that are just going to be, okay, so in case the choice is any of these things, do this particular action. And then the reverse of case is going to be ESAC. That's how you close out the case loop. And then at the end of the while loop, we're also just going to write done. And that's basically it. So this is a little bit more complex on the command list, but what we're going to do first and foremost, while the choice is not Q. So while they have not chosen this specific option, which would be choice number three in our case, while their choice is not that, do any of these things. You can either print echo hello world for them. You can print the date for them. If they do choose Q, it's going to be goodbye. If they do an invalid option, we're just going to say, hey, this is an invalid option. These are the four case scenarios, okay? Then once these things have been echoed onto the screen for the user, their response is going to be stored inside of this little prompt here. So we're going to read the value of this prompt. So that's what P is. We're going to read the value of this prompt and we're going to store it inside of our actual choice variable here. And then this is where the in case portion starts, where it says, all right, so in case the choice is actually inside of any of these things, then I want you to do any of those things and then finish it off in case anything else is done. So the while true portion is as long as the choice isn't quit. So if I just keep saying one, it's just going to keep saying hello and it's going to keep saying hello. It's going to keep saying hello. If I keep saying two, it's going to keep showing the day, keep showing the day, keep showing the day. Until I actually choose Q, this is just going to keep running because my conditions are going to be true the entire time, right? And that's basically how it is. As long as I don't choose Q, it's going to stay true and it's just going to keep running that script. When I do choose Q, then it turns into a false, meaning the choice is no longer not Q. The choice is actually Q. So when this becomes false, then the loop will break and it'll just say goodbye and it's going to move on. So we're going to write that, going to exit that, and we're going to run this thing. And there we go. So binary operator expected. So I did not include the proper binary operator. So let me just make sure that I actually have this. And I think that's what I was missing. So let me go back here. Let's go into the nano loop.sh. And I forgot to put the binary operator here. So it's not equal to, it's going to be not equal to Q. That's what we got to do. That's the part that I forgot. So boom, write that out, close that out, and go and do the loop sh. So there we go. So it says say something. So I'm going to say one, press enter. It says hello, hey, so here's another option. Say something else. And I'm going to say one again. And it's going to say hello again. And now I'll say two. Okay, show me the date. Now it's going to give me the date. Look at that. Your choice was two, and it gave me the date. Now I'm going to say four. And then it's going to say that's an actual invalid option. That's not one of the options that I gave you. You can either do 1 through 3, or 1, 2, or Q, right? If I do 5, it's going to say also that is an invalid option. You need to do something else, right? So in that particular case, we're now going to do Q and it says, okay, good job, bye, we're done. That's it, right? Very, very simple, like a really, really easy command. I think I forgot to actually echo the goodbye portion, but it's supposed to say goodbye to me. I don't know why it didn't say goodbye to me. My script isn't polite. It didn't actually say goodbye to me. That's very rude. But that was it. That was the option that we had. And that is how the whole thing works. I think it's because I actually did three instead of Q. So what we need to do is we need to go back inside of this. And instead of three being the choice that we have over here, for this echo command, we're going to do Q as the echo command. And now I believe that should be the option that's going to work. So we're going to run this one more time and clear the screen. And we're going to go and run the loop sh. And we're going to officially do Q, press enter, and it actually does say goodbye this time because the option was appropriately designated. So that is one of the more complex scripts that we can create with while loops. And in this particular case, hopefully you do understand how like how far this can go. And I do need to explain a little bit more about the actual case in case portion of this, the conditional, as well as if statements, because we're going to work on if statements as well. So I'm going to cover those two so you get a full understanding of these control constructs. So for loops, while loops, if statements, and case statements are all part of the control constructs. So we covered for loops so far, we've covered while loops, we've touched on the case statement, and then we're going to go deep into the if statement as well as the case statement, and then that'll be it for our control constructs under shell scripting. All right, so now we are going to be talking about if statements, and this is a comparative statement. And if statements are a part of the control constructs as well, and they are a very, very big piece of automating tasks and actually creating what we like to call algorithms. So when you start combining control structures, the various control structures together. So when we combine the for loop with the while loop, as well as the if statement, and then what you already saw, which was a case statement, if we start combining these things together with their combinations, we can actually start developing algorithms. So it goes a little bit past the concept of automating a task, and you start doing some really complex series of commands, which is actually very, very useful. I've done this in a lot of different cases, dozens of different scripts right now in the Python language. So doing this in the Bash language, or what we call shell, doing this in shell scripting is very, very interesting to me. And the more I learn about it, the more interested I become, because the shell scripting is very intuitive, and it comes along with most operating systems. So you can create a shell script without having the Python language for the most part, and you can create it inside of a Windows environment, inside of a Linux or a Mac OS environment. So this is not something that's just limited to one operating system. Of course, the syntax would be different if you were inside of Windows. They use PowerShell and the command line, CMD, for example. So some of those commands are going to be different, but the overall concepts are the same. And it's the same thing here as it is in Python as well. So we actually do have things like for loops and while loops and if conditions or if statements. We do have all of these things in Python as well. It's just the syntax is a little bit different. So if you can wrap your head around the concept here, then you'll be able to essentially learn it in any language. Now, what I like about the shell scripting and the bash and the syntax that is included here is that it is very similar to Python in terms that you're using actual words here. So we say if, then this, or else do this, if, etc., etc. So when you go through this, you'll see that it is fairly intuitive, and you can actually, hopefully, you'll quickly be able to wrap your head around it. So this is the basic constructs of if statements. So this portion that we have right here is the most basic version of it, where we say, if this condition is met, then I want you to run this command, else I want you to run this other command, and then phi would be the backwards version of if, which meaning that this is the end of this if statement block. Okay, so if this condition is met, then I want you to do something. Otherwise, meaning else, so if this, then this, or else do this other thing. We don't put the word or in here. But that's basically what the conversation is like with the language that you're interacting with, right? So you say, if this condition here's here, then I want you to do this, or else I want you to do that, and then that's it. So this would be the basic version of an if statement. We have the version over here where we say, if this condition is met, then I want you to do this. If, and then we have another condition that we can actually feed into this. So technically it would be if, and then condition 2 technically here. Then you would do the next thing, and then we can just keep running if over and over and over again until we meet all of our conditions. And then after that, we would have one final else condition or else statement, and then we would wrap up the if statement block. So this would be a block of code here, and this entire thing would technically count as one if statement, right? So there's the if statement that starts the whole thing, and then we have multiple sections where we have the bodies of the code. But apart from that, that's pretty much it, right? This is like the overall concept here. So if something happens, then I want you to do this, or else I want you to do the other thing. Or if something happens, I want you to do this. Else if, so or else if something else happens, or else if something else happens, I want you to do these other things. And then if none of these conditions are met, then you can just move on and do the last else statement. And then from there, we'll move on and finish the overall block, which is what the phi or phi at the end would represent. So now that we know this, we are going to actually start writing some if statements so that you can see how useful this actually can be. So the name of the file that I have right here is now a new shell script that we've created. It is called the if.sh file, so if shell script. And the very first one, we just want to check for the existence of any given file. So we would start with if, and then we would say -f representing that we're checking for a file. And then we're just going to look for the file.txt name. So let's say in the current location that we're at, we're looking for this file. So if that file, if file, we're basically saying that exists. So if this condition is met, it means that this file exists, right? So if file.txt is actually true, if it does exist, then I want you to echo to me and say file exists. It's very simple, right? It's like not complicated. This is what I'm saying. It's very intuitive. Else, I want you to echo to me file does not exist. Simple, right? This is the most basic version of a if statement that we can run here. So if the file does exist, then tell me that it exists. If it doesn't exist, then tell me it doesn't exist. Very simple, right? So let's check that we actually do have a file.txt inside of this location. So what I'm going to do is I'm going to change the permissions of my if shell real quick, just so I can actually execute it and it's all good. And now we're going to do dot to say that we're in the current directory /if.sh. And that's all you have to do to run a shell script. Press enter, and it says file exists because we can see that the file.txt is actually inside of this location. Now, I don't have file2.txt, I don't have a number of other files, so we can actually go back into this and just check to see if this condition will actually work if there is no existing file. So if there's no file3, for example, I know for a fact, because we just saw it, there's no file3 on our screen. So we will now run if.sh, and it says file does not exist. So very, very simple script, but it's functional, right? So the concept here is that maybe you want to check the contents of a given directory, right? So if you are looking for a file inside of a directory that has a massive number of files in it, then maybe you don't want to manually look through it and you just want to do this little script. It's like, it's such a simple little script. It's literally, again, it's like, what is it? 5 lines of code, technically. If you look at from here all the way down to here, this is technically 5 lines of code, but they're such simple lines of code that you can literally write this in a minute, less than a minute. And then now it will serve the purpose for you. And then it can search through a massive directory of files to see if a given file exists. You can also do this with, if you're searching, let's say, inside of a document that has a bunch of text or a log file. For example, you can search the contents of a log file to see if a certain phrase or a certain IP address or something exists inside of the log file. And if it does, then it'll tell you and it'll pull that data for you, very similar to what the grep binary does for us, the grep command. But we can actually write our own script for it to customize the search and show us everything else that potentially may be available and just customize it in all the different ways that we want to, really. So this is one version of the if statement. So another one is that we can now do a comparative if statement. So we actually did, I was mentioning earlier that we have an assignment equal. So for example, when we use one single equal sign, we are assigning a value to a variable. So in this case, this singular equal sign is assigning this value to this variable. Okay, so in this case, that equal sign is an assignment operator. Now, what we have over here is the comparative operator. So if I go look at my name variable here, and I will do equals and then equal again, and now I am comparing. So I'm saying if name equals to John, and then we close this with our square brackets, do a semicolon, then I want you to echo, hello, John. Very simple, right? Finished. That could be one thing. You could also say if, or we could just add an else in here and say echo, you are not John, so goodbye. There we go. And then we can finish the script. Very basic, right? So if the name equals John, then hello, John. If the name does not equal John, then we can just say you are not John. So this is one version of the script that we can write over here. And we can now test this, right? So I can go and say if.sh, and of course it's going to say hello, John. And this is kind of a little bit, I would say, counterintuitive because now we have to go in here and actually assign this comparative or this specific variable's value. We would have to assign it inside of the script. So here's what we can do in this case. So we can say read the prompt and then it says what is your name, and then it would read this and then it would read it into the name variable. Now it's going to prompt us and it's going to ask us our name. And if our name is John, it can say, hello, John. And then let's actually do some more piece right here. Welcome to the system, for example. And then the other one would say, you're not John, so goodbye. And then we'll do one more thing. You can't access the system, right? That's kind of, it's a little bit tongue in cheek, but I think you get the idea here. So now we're going to run the if.sh and it says, hey, what's your name? And I'm going to say, my name is Hank. And say, you're not John, so goodbye. You can't access the system, right? How simple is that? If sh, what is your name? My name is John. Hello, John. Welcome to the system. You see how it is? It's very, very intuitive. It's like fairly easy to actually write this whole thing. So if.sh, and we were able to just make it a little bit more complex by just giving a prompt to the system and then reading the value of that and putting it inside of the name variable instead of coming inside of the script and then saying, okay, this is the name or this is what the name is and so on and so forth. But the crux of it, right? The full function of this is here. This is the big piece of this particular script is that it's actually comparing. This is the comparative equal sign. If name equals John, then you're going to do this. If name otherwise, it says you're not John, so goodbye. And then we can just as easily come over here and say if name does not equal John. So now in this case, we're saying that this person is not John. So if the response of this is not equal John, then we're going to say, who are you? I don't know you, right? If name does not equal John, we'll say, who are you? I don't know you. If it is John, right? So this is basically just flipping the whole thing around. So if it doesn't equal John, the system is going to ask, who's this person? If it is John, it says, oh, hello, John. whatever, haven't seen you in a while. Something like this. Some like crazy, ridiculous tongue in cheek. I'm creating like this little AI conversation for myself right now. So there we go. So what is your name? My name is John. It says, "Oh, hello, John. Haven't seen you in a while." So we basically just reversed it. So it's saying if it does not equal John's, which is we're assuming that the person who is going to come in here most likely is not going to be John. So if I say, "Yeah, my name is Hank," it's going to say, "Well, who are you? I don't know you." Right? And then this would have to continue to be another conversation. So technically, so now again, I'm again kind of getting a little bit ahead of myself. So forgive me. I want to do one more iteration, and then after this, we'll finish here. So if the first one is what is your name? I'll say my name. If the name does not equal John, then instead of echoing who are you, I don't know you, because this is actually technically another prompt for a variable, right? So in this particular case, I could actually go over here and I could delete this instead of saying echo who are you, I don't know you. I can actually say read another prompt and it would say who are you? I don't know you, and that would be the prompt. And then it's going to read that into the name variable one more time. And then in this case, we can go in here and now assign another if statement. And if we say if the name over here, and maybe if I don't want to confuse myself, or let's say confuse you, we'll just do name1 as the second variable. So if name1 is not equal to, or is, yeah, I guess is not equal to, let's see, let's give it Jill. So Jill would be the only other person that can access this, right? So it would say read, so it's going to prompt again. So who are you? I don't know you. And then we would store it inside of the name1 variable. And then we would say if name1 is not equal to Jill, and then we are going to go into here and say, this other, so we have to now, we're going a little bit deeper into our if statement. So we have two if statements, right? So if name1 does not equal to Jill, then we're going to now echo, you are not anyone I know, goodbye, right? Boom. Then we can go here and we can say elif, okay? Elif, let's see, where am I? Right, elif, actually I do need to go up here and give it another condition. So elif uh, name1 equals to Jill, then you can come out and say, oh, hello, Jill, been a while, whatever, right? And then after that, we can finish this particular one. And then in this particular case, then we can go over here and just make sure our else statement right here, it would be the continuation of this piece right here. And hopefully I haven't messed up the indentations. I feel like my indentations are actually pretty solid in this particular case because I am a little bit used to the particular Python language. So it is kind of similar to Python. So hopefully I haven't messed this up. Let's see. So it says, what is your name? It'll say Hank. Who are you? I don't know you. Um, and this is kind of redundant because we literally already asked them their name. So if I say my name is Hank and then it says who are you? I don't know you, and then I'll still say Hank. It'll say you're not anyone I know. Goodbye, right? So if we run it again, that was actually kind of like a redundant thing. I was just trying to show you that you can put two different prompts inside of the if statement and then you can kind of collect more information. But as the script ran, I'm like, oh, I already told it my name, so this kind of doesn't make sense. So if I do Jill, it'll say, who are you? I don't know you. But it's like, well, it's me, Jill. And it's like, oh, hello, Jill. It's been a while. So that's kind of weird because I'm already asking the first time, what is your name? And it says, who are you? I don't know you. And I'll say again, I'm Jill. And it says, oh, hello, Jill. It's been a while. Maybe that one kind of makes a little bit more sense. The final iteration of this, of course, if we just come in here and we say we're John, it says, oh, hello, John. I haven't seen you in a while. So I do realize that looking at the script now, I just wanted to make it a little bit more complex just to kind of flex my muscles and say, yeah, you know what? I can actually put another if statement and an elif statement inside of this original if statement, and then we can kind of build it out like this. And then to make it a little bit even more user friendly, right? You can technically actually break this down by just pressing an enter here so you can see these separated portions. So it's a little bit easier to read. You can do that technically. And then you can see that this is actually its own if statement that is inside of this much larger if statement. There is the concept that you need to put the fi at the end of this one to make sure that this is closed, and then you need to put the fi at the end of this one to make sure that that's closed. Otherwise, the script won't work for you. But that was really mostly the purpose, because once we ran it, I'm like, oh, well, this is kind of a redundant question and it doesn't make sense. Whatever. But now you see that at the very least we can put two if statements together. We can combine one. We can put one inside of the other one. We can do multiple prompts of collecting people's information and their name and storing them into different variables, and then accessing those variables, calling on those variables is the technical term. So we can call on those variables throughout our script and use them to build a more complex script that is putting together these if statements, these kind of comparative control functions, I guess is what we were called here. So that was another version, control structure, I think is what it's called. So that was another version of creating our little if statement. And then we can now go and do some other examples of this. So the very first one that we did was to check to see if a file exists. We can actually do the same thing, and we can, instead of using -f, we can actually do -d to see if a given directory exists. So if I say home Cali, right? So if this directory exists, and I think actually I need to do this. So home Cali. If that directory exists, then I want you to echo to me that directory, I can't even spell, directory exists, right? Else, echo not exists, whatever, just to make life easier. And then you would finish it up. So now we can essentially check for the existence of a given directory. We know for a fact that we're actually inside of the Kali user. So in that case, we can actually go and check for this. But again, this is one of those things that I would have to come in here and I would have to change this portion of it to check for the existence of that directory. So instead of doing that, why don't we again just create another read prompt that says what directory do you want to check for? And then do this, and then do an example where we say e.g. home Cali as an example, and then close that off, and then store it inside of the directory variable. And then from here, instead of actually searching for the directory, we will just put the, directory variable. We can go over here and we can just put the variable directory. So if the directory does exist, then I want you to echo that it exists. If not, tell me that it doesn't exist. So now I can go ahead and run it, and it'll prompt me for my question. So what directory do you want to check? Example, home Cali. And I should have put a space at the end of it and made it a little bit more user-friendly. But for in this case, I'm just going to say home Cali. I do want to check that, and it says directory does exist. I do want to fix it because I'm a little bit weird when it comes down to user friendliness and being able to read something easily and interact with it. So what we're going to do is we're going to put a colon at the end and a space so that when we actually do run it, it's a little bit nicer on the eyes. So we will do this now. And now we have a little bit space at the end. So instead of doing that, I'll just do home bill, for example, because I know we deleted bill's directory. So it says it doesn't exist, right? So now we're interacting with the script. Instead of having to go in here and manually change the value of this portion, we're now interacting with the script. And we're creating a prompt that's going to ask for a certain response from us, and then we'll store that inside of a variable, and then we call on the variable throughout our if statement to make sure that, it is existing or it does what it's supposed to do, so on and so forth. So this is how we check for a directory, is by using the -d option here instead of the -f, which was checking for a given file, right? So that was another version of an if statement that we just created. So now we can kind of get a little bit more into the portions of finding out, for example, if variables are actually, if they contain data, and to do something, if it does contain data or if it doesn't contain data, so on and so forth. You can just do that. And that one is very, very quick. So I'm going to create that one real quick. And then I do want to do another one that was very similar to our while loop that we created earlier, that it was checking whether or not a number was greater than a certain number or greater than equal to or less than or equal to a certain number. And if it was, then it would say that something is true, or if it's not true, it would give us a certain statement. And then apart from that, it would do something else, right? So we can actually create a few different versions of this, and then we're going to combine multiple conditions in one line. So we're going to do a few different examples. The next couple are going to be very, very simple, but they are meant to show you the demonstrative power, or they're supposed to demonstrate the power of these if statements. And then from there, we're actually going to go and build a couple of pretty advanced ones, or more than beginner. I would say they're not advanced, but at the very least they're pretty useful. And then hopefully it'll really give you a big picture of what this thing can actually do. And then we'll go into our case statements, and then from there we'll be done with our control constructs. And then after that, we'll be able to actually go and create some decent scripts. So here we go. The next one is going to be, we have just a variable called variable, and then there's going to be a value inside of this variable. And then, so obviously that variable is not empty, right? So we can now say if the -z flag of this variable, and this essentially means that if it's empty, so -z in this particular case, I believe stands for 0. So if the content of that variable, that var variable, is empty, then I want you to echo to me that variable is empty. So it's just, we're just demonstrating the power of this -z portion that is checking to see if a certain variable is empty or not. So if that thing is empty, then I want you to tell me that it's empty. Otherwise, I want you to tell me, echo variable not empty, right? That's basically it. And then finish it off, write it out, exit, and then run this thing. And of course, it says variable is not empty because, as we just saw, we put something inside of the variable. If I went over here and deleted the contents of that variable and just left it at that, and we close this out and we ran it again, it'll say that the variable is empty because we literally just emptied out the variable. So this is actually something that you can check to see whether or not a script is actually running the way that it should, or if it actually has the contents as it's dealing with user input. For example, if you're expecting something from a user and they don't give you the value and they just leave a certain variable empty. So you'll see this a lot with information capture forms on websites, that they have certain fields inside of the information form that are necessary, they're mandatory. And if you don't fill it out, that means that variable for that field of that form is now empty. And so instead of the service telling you that the variable is not empty, it's going to say that this field is required. And then you have to actually go back and look at it and then fill in that field. So this is where the function of that actually comes in. So if you're creating some kind of a interactive script or some kind of a form, and then for whatever reason you're using the bash shell scripting language, and in that situation you would just go and use the -z option to see whether or not your required fields are actually empty or if they actually have their value. And then if they do, then the script can actually continue to process. If they don't, then you can remind the user that, hey, you need to fill in this particular field because it can't be empty. I have no value for this field, right? That's essentially what we're doing in this particular example. We're just checking to see if a given variable is empty or not, if it actually has value inside of it or if it doesn't. Now, the next one that we want to do is very similar to what we ran when we were creating our while loop, which is going to be, we're going to create a number variable, and the number variable will do 5. And what we're going to check in this case is if the number variable here is greater than a digit. So we'll say greater than 3. If the number variable is greater than 3, then I want you to print that the num here is greater than 3, right? That's basically it. To make it a little bit juicier, we can actually say num2 is whatever, 3. And then in this case, we'll say num is greater than num2, right? So if num is greater than num2, then we want to say num is greater than num2, right? So now we actually have this full functioning script that's pulling from two different data points, and we don't have to go and edit this piece and then edit this piece for it to make sense. So then I can go down here and then I can just finish this, just keep it simple, write that out, exit, go here, and then we're going to say this. And then, so let's see, num2 command not found. The operator is not found. Okay, so now I need to make sure that my syntax is right. So that is the one thing that I have to make sure that I'm actually really good at doing. So I have num and I have num2. I think it's maybe this piece right here that I'm used to, again, dealing with Python, and I'm putting extra spaces. Maybe that's what it is. So let's run that one more time. And there we go. So that did work. So that was what was wrong with my syntax. Again, because I am so used to writing Python. So in Python, you can technically do a space between the variable, the equal sign, and the value of the variable. But in shell scripting, apparently you can't leave a space between the variable, the equal sign, and its value. So now we actually have this, and it's very, very useful. So now if we go over here and we'll check this piece right here, and we will do again 4, for example, and then we'll save it and then close this out and then run if.shell, and it's going to say 5 is greater than 4. So it's checking for digital values. It's checking for integer values inside of this shell script, okay? I have to now add another piece to make this even more functional. So if I actually go here and I'll say else, so if it's greater than num2, great. If it's not greater than num2, then we're just going to say num is not greater than num2. That's it. So that will be the else portion of this. So now I can actually go over here and I can change this into 6 to try to test this out. And we'll go and run that. And it says 5 is not greater than 6. Wow, would you look at that? Our script can actually do basic arithmetic and find out whether or not something is greater than 4. But that's basically it, right? So the main purpose of this is we're checking a few things. We're doing a few things now that we did not do before. Now we have two variables, so that's the first thing. The second thing is that we are now checking whether or not the value of one variable is greater than the value of another variable, and then we have the rest of our if statement, which is very similar to what you've seen so far. We're pulling two variables inside of our echo command, which will allow us to actually interact with these two different variables over here. So that's something that we haven't done before. And I want you to hopefully notice that when we're dealing with integers, we don't put the variable inside of a quotation, because the instant that you put it inside of a quotation, you are now turning that variable into a string. So if I actually did this, it wouldn't work. This greater than symbol right here, this greater than operator is not going to work. So I'm going to actually show that to you now, and oh, it still worked. So I guess never mind. So I'm thinking about Python, and apparently the rules does not apply here. So in Python, if I did something like this, technically, I would have turned it into a string, even though it's kind of funky because now it's still referring to the original variable, and the original variable is still an integer. So maybe this doesn't actually mess with it. So we can, from now on, we don't even have to put our variables inside of quotations, whether or not they're numbers. If you just put them like this, then it'll still work. So in previous examples, we were putting them inside of quotations to check whether or not they're actually decent, because the one that we did for the one right before this one where we were checking to see if a variable was actually empty or not, we did put the $ var, the $var. We actually did put that inside of quotations. And I thought that was kind of the rule. I thought that was the given rule that if it's a text-based or a string-based variable, then it has to be inside of quotations, even when you're referring to it. So obviously, it would have to be inside of quotations when you're creating the string-based variable. But if even when you're referring to it, I guess you could technically just leave the quotations out. As long as this portion right here is inside of quotations, then you can consider it to be a string-based variable or text-based not alphanumeric, alpha. It wouldn't be alphanumeric. I think it's just alphabet or a text with string, whatever. Literally, my mind is like, dude, where are you? What are you doing? Okay, but the whole purpose that I just wanted to show you in this case is that we actually have two variables here. We were able to compare the two variables inside of our if statement header, and then we were able to also access both of those variables inside of our echo command to print them onto the screen. So that was the one other example that we had for this. And we can now move into the other example that I have here. I have, I think, how many? I think two more. I have two more examples inside of my notes that I wanted to share with you, and then we will move on to our case comparative operator, our case statements. So here is the other one. In this particular case, what we're going to do is we're going to create, and we kind of already did this with the exact example that we were just looking at, but I'm going to make it a little bit more fancy for you, okay? So we're going to say if the num, so we have to refer to it with the $ because we're referring to a variable. If the number is equal to the number 5, then I want you to echo to me that the number is 5. Okay? Elif. So we have to now give it another condition. Anytime you do elif, you have to give it another condition. Elif, if the number is equal to 10, okay, then I want you to echo that number is 10. Okay? So far, pretty fancy stuff, right? And then we have an else statement that's going to say if it's not equal to 5 and if it's not equal to 10, then I want you to echo to me that number is neither 5 nor 10. Fancy. So now, since I have this, instead of doing this, what I want to do, you probably guessed it, is I want to create a prompt that says, what is the number you're thinking of? Okay. And then we'll give it a space, close that out, and then read that into the num variable. Save that, close that out, and now run this bad boy. So what is the number you're thinking of? I'm thinking of 5. The number is 5. Oh my God, really? Okay, let's run that again. What is the number you're thinking of? I'm thinking of 10. Oh my God, the number is 10. Oh my God, you can read my mind. Let's run it one more time. What is the number you're thinking of? I'm thinking of 4. The number is neither 5 nor 4 or not 5 nor 10. And it's like, oh my God, how did you know? How can you tell, right? So there we go. So now what we've done in this particular case is that we've created two different conditions. We are now using the same exact variable that is the num variable here. We're using that same exact variable. We're using these operators for integers that are the equal to operators. So equal 5 or equal 10. And if it does equal to 5, it's going to echo this. If it does not, or if it does equal to 10, it's going to echo this. Otherwise, meaning if it's 1 through 4, or if it's 6 through 9, or if it's 11 to infinity, essentially any of those, or even 0, right? So 0 to 4, and then maybe even negative, because we haven't changed it we haven't given it the specific parameters to actually look for the absolute value of something. That's what I was looking for. So we haven't given it the parameters to look for the absolute value of something. The only thing that it's doing is doing a literal comparison. So if we give it -5, it still would say the number is not 5, right? It still would say number is neither 5 nor 10. And let's actually run that, right? Because I am curious if it will work with absolute value. So if I do -5, let's see what that works. -5. Yeah, number is neither 5 nor 10 because it's not looking for the absolute value. And technically, -5 is actually not 5. So that is a very important distinction to make. So this is very, again, another simple script, but we're just demonstrating the possibilities here, right? So you can create a prompt at the top, read the value of that prompt inside of this number variable, and then use these comparison operators. What did I just do here? Oh no, I don't know how to. What did I do? I didn't even know you could do this. How could you even do that? Ugh, okay, let's just close it out anyway. We're not going to save this and come back into it. So we're just using a couple of comparative operators here and so on and so forth. You already know what's going on. I don't need to beat a dead horse, as they say. So we can move into our final example for our if statements, and then we'll just go into case statements, and then we'll wrap up the control constructs, and then from there we'll move into some of our more advanced stuff. So I keep calling it control constructs, but it's control structures, control structures, control structures. I apologize, control structures. And in the notes, in the timestamps, you'll also see control structures. Just forgive me. I am running on fumes. I've been recording for 3 days up until 3 or 4 in the morning because I made a certain promise to somebody in our community to try to deliver this as fast as humanly possible. And I'm trying to meet that promise. And for a variety of different reasons, it has been quite challenging. So, all right, finally, our last statement here, our last comparative if statement. We're going to give a new variable here. So it's going to say read the prompt, and it's going to say what is your, actually, instead of doing what is your age, nobody says what is your age. We're just going to say how old are you, right? There we go. And then we're going to read that. We're going to assign that to the age variable here. This is very much the same thing as me actually hard coding into this and say the age is 25. That's basically what I would be doing if I wanted to hard code the value of this specific variable, but I don't want to do that. I want to make it interactive, and I want you to get used to creating interactive scripts. So we're going to read this specific value here, and it's going to be from this prompt. So if you want to create a prompt, you just do -p, how old are you, and then read the value of that inside of this variable. So there we go. So now it says, how old are you? Okay, so if the age, right, the age variable, if that is greater than or equal to 18, right, and then we can close that out, and then we do our double ampersands, and if the age variable is less than or equal to 65, okay, you can probably guess where this is going. We're going to echo that you are of working age. You can work, basically, right? Else, echo you aren't of working age. How complicated is that? And then finish the script. And that's it. So the big demonstration here is creating two comparative statements inside of our first header. So instead of doing if age is da 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 and or elif ages da 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 da, right? So instead of trying to do something like that, we're actually assigning two required conditions. The first condition is greater than or equal to 18, and this one has to also be true. So in order for this echo command to work, both of these conditions actually have to be true. They both have to be met in order for this to work. And the way that you can do this is by doing the double ampersand and essentially just assigning whatever your conditions are inside of these square brackets. And hopefully you understand the context of these conditions. So if we're doing digital or integer comparisons, we would be doing the G and E. And we went through all of these operators already when we were working inside of our the scripting when we started, not scripting, but when we started the command line training at the top of this video. We were looking at these comparative operators. So we had the double equal sign, which was for strings, and then we have the dash G and E or L and E that we see right here, and then we have GT, which would be greater than, LT, which would be less than, so on and so forth. So these are all of the operators that are used for integers. So as long as you are creating your condition correctly, you can technically combine multiple conditions, right? And then you would say semicolon, then this is what I want the script to actually do. Otherwise, this is what I want the script to do. And now I'm going to ask the question from the user, and we're going to see if our user is of working age. So if sh, here we go, how old are you? I'm going to say I'm 38, and it says you aren't of working age. So line 4 is missing something. So I think it's missing. Let's go into line 4 and see what I'm missing here. So if da 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 da, then da 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 da, you are of working age, else you are not of working age. So what am I missing here? I feel like I shouldn't be missing anything. Let me see what I'm missing. I think it is the last space here. There we go. So it's our last little portion here. These spaces are very, very important in shell scripting. It's not the same uh, situation when you're doing Python. Python is not this strict with spaces. And I find this to actually be quite an interesting difference between shell scripting and Python scripting. So the main reason that I saw, the main difference that I saw, that literally the only thing that I noticed is actually there was no space here. So this is what it looked like here. This is what it looked like, where there was actually no space here. So I just needed to create that space. And this is line 1, line 2, line 3. So this would be line 4 of our script over here. So now we're going to press enter and we're going to go out and we're going to run this one more time, and it's going to say, how old are you? No problem. So we're going to do 38 and you are of working age. So everything's all good. Let's run that one more time. How old are you? I am 15. You are not of working age. And let's run it one more time. How old are you? I am 70. And it says you are not of working age. So now we can actually interact with our script, and we have combined two different conditions inside of the same header, which would be the age greater than or equal to 18, age less than or equal to 65, and those have been combined using the double ampersands, and this is now serving as one big condition. Technically, there are two separate conditions, but this is one whole condition that elicits this command right here. So if this condition is met, then this person is of working age. Otherwise, you are not of working age. And that's basically it. That's all of the examples that I have for you for the if statements. And what we can do now is we can just close this bad boy out and go to our contents here, and we can see that we have now established a good amount of um, scripts that we've developed. So one of the things that I want to do just to make the desktop a little bit cleaner is I'm going to take all of these documents, all of these text files that I have, and I'm going to put them inside of these directories. And I do want to see if these things actually have anything in them. So dir2 has the directory in it. dir3 does not have anything. So we're going to remove dir3, and you can remove, so remove -r dir3. You should be able to do that now. There we go. So now we've removed that. And technically, I can even remove the dir2 because it's basically a duplicate of directory. So we can remove dir2, and it says remove written protect regular da da da. Write protected. Yes. Okay, wait. What's going on here? I think I need to do a sudo command. So sudo rm-r dir3 sudo rm. Okay, there we go. So we have that. So now we're going to look inside of our directory. We have file2 and we have file. And let's see, I think we need to, all right, I'm just going to do my house clean. I don't need to explain all of these things to you. And then I'll see you on the other side for the case statement. All right, we have now arrived at our last portion of the control structures, which is going to be our case statement. And the case statement in shell scripting is used to handle multiple conditions more cleanly than creating a series of if and elif statements. So if you have a bunch of conditions, instead of just doing if, elif, 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 you can essentially just create one case statement and then provide multiple conditions. So it'll end up simplifying the code when you need to compare a variable against multiple possible values. And this is basically what it looks like. So let's actually create a new one called case.sh, and we will do our shebang at the very top, which is going to be the bin bash as always. And we'll add another comment here where we will call this the case statements, and we'll have another comment, and then we'll do example one for now, but this is more the descriptor, and then I'll give you example one, and then I have a number of examples available for you. Okay, so here we go. So this is the basic syntax of the case statement. So we have case that elicits, it calls on the case command or the case comparative, the case statement itself. Then we need to give it a variable. So case variable in, and then press enter. So the next line, and then you would have to go and indent. So typically the indent doesn't look as crazy as this. Typically it's like 4 spaces. Usually that's what an indent looks like. But when I press tab on my keyboard, that's basically what happens. So you indent once, and then you give it a pattern. And so we'll say pattern 1, and then it closes off with a parentheses, okay? And then inside of pattern 1, you would essentially have your either one command or series of commands. So let's say we have a series of commands in this, so we would have to indent twice under it to just make sure that everything falls under pattern 1 here. And then we would have command 1, and then we would do command 2, and then let's say you have multiple commands or whatever it is, okay? So that would be the pattern 1. That would be a potential option for the match for this variable, right? And then we can go over here and then do pattern 2, and then close that off with a parentheses, and then go command 1, and you get the concept here, right? That's what the overall structure for this would look like. And then I have missed one very important element here. When you do this, you need to close it off with 2 semicolons. Otherwise, it will not work. It'll give you a logic or a syntax error. It'll give you a syntax error. So in order for this to actually work, you need to, at the end of each one of your patterns and its options for that pattern, you have to have the 2 semicolons. Otherwise, you are going to get a syntax error and it's going to break your code, and then it's not going to work. So that would be essentially it. And then we can go lower down here and provide more if we wanted to, or just finalize it and then go ESAC and close it off, right? So everything in Bash, as you've probably noticed by now, has to be closed off. So if there is else, or if there is if at the very end of it, is going to say fi, so which would be the reverse of if. If we have, for example, for, if we have a for loop, by the end of the for loop to end it off, you would just say end. That would technically just be the end of the for loop, or done, excuse me. Done would be the term, the word that finishes it. Same thing for a while loop. The last word to close it off would be done. Same thing for the while loop, same thing for the for loop. For if, the last word would be fi. For case, the last word would be esac, or the just a reverse spelling of case. That's basically how you designate that you've closed off your case statement. So this is the basic structure of what a case pattern or a case statement looks like. You have the case header, and then you have the body of the case statement that would have one pattern, and then if that pattern matches, then you have a series of commands that would execute for that pattern. If you have another pattern and then that matches, you have the series of commands that would execute for that pattern, and so on and so forth. So this is our general syntax for writing a case statement. So now that we have this, let's actually use this so that you can see what the examples are. We've done this once already, but I do want to show you what it actually looks like. We'll run a few other examples so you really have it kind of driven home here. So actually, real quick, before we go into our example, I forgot to show you this one last portion right here, which is represented by our default case right here, this asterisk, this last point right here. This is very similar to having the else command inside of an if statement. So when you say if do this, else it has the final default. So if something happens, do this, otherwise do this other thing. This is what acts as else for the case statement. So you essentially have something that would be, these are your elifs, for example. So you have if, and then you have all the various options, and then this could go for as many iterations as you want. So you could have 10 patterns, and then the very, very last one would be the final else statement that would say, okay, this is the very last thing. And if none of these patterns match, then this would be the last thing that you would do. And then you would finalize it that way. So this actually is necessary. So you can have as many patterns as you want, but you also do need to close off your options for your patterns with this final portion, which in this particular case is the asterisk acting as the default case. And it's executed if none of the patterns match. And it works like the else portion of the if statement. And then, of course, the double semicolons will also act as the end for this little default statement as well. And then from here, we can make sure that we can wrap it and close it off. So I just wanted to make sure that you also had that before we continue on to the examples, because I am going to demonstrate several examples and it is going to show this piece, and I didn't want to not have explained it to you before we go into the actual examples themselves. So let's now go and create the examples. Okay, so this is our first example, and we have a very basic series of conditions here. So in this particular case, the number one, the $1 portion here is the first argument that's going to be sent into this particular script. So when we actually run this thing, we will have a command line argument that we need to provide to it. If we don't provide it any kind of a command line argument, it will just say unknown command. If we say stop as our argument, it'll say stopping. If we say start as our argument, it'll say starting. So that's basically it. So the case is the first position, the first command line argument that is fed into the script as you run it. If it's start, it'll do this. If it's stop, it'll do this. If it's anything else, if it could be a blank response, so you run it without providing any kind of an argument, it'll say unknown command. So we can actually even do that just to kind of give this a little bit more of oomph right here. So blank argument or unknown command, and we could just save it like that, close that out. And so let's actually run it. So case sh without any argument. So it says blank argument or unknown command, and I'll run it with the start argument, and I'll say starting. I'll run it with the stop argument, and I'll say stopping. So that's just the very first example, the very basic example of creating a case statement and then providing it technically 3 different variables to choose from, which in this case was the start, stop, and of course the default at the very end that just says either this was blank or we didn't have anything in it. So that was our very first one. So let's go and write out the second one. And then I think the better pattern is for me to actually write out the full thing. And then once it's written out, I'll just break it down and I'll start explaining it to you. Okay, so here is our new case example. So in this particular case, we have a prompt that we're going to give to the user that says choose a color. And then we're going to read the response to that prompt and we're going to store it inside of the color variable. And then in case the color variable, the response is red, we're going to say the color is red. If the response is blue, we're going to say the color is blue. If the response is green, we'll say it's green. Any other response will say either blank variable or color is unknown, basically. And again, very, very basic. But what we're doing in this particular case, I love saying it like that. What we're doing in this particular case, instead of feeding the script an argument, we're now running it based on the prompt that's given to a user, and then the user will feed us the response, and then we're going to take that as a variable and then compare it to all of the options that we have here inside of our case statement. So we're going to write this out and we're going to run case in this case and run it. And now I didn't have to give it an argument because I'm going to interact with it. So it's going to choose a color and I'm going to say yellow and it's going to say blank variable or the color is unknown. So I'll run it again. And then now I'm going to say red, it says color is red. I'll run it again. I'll say blue, it says color is blue. So you get the picture, right? So of course it's going to work because we actually wrote a great script and every piece of it is going to function. But that was the second example. So in this particular example, in this particular case, I love saying this, in this particular case, we actually fed the variable by using a prompt to make it interactive, and then that prompt fed into the variable itself, and then we were able to compare the value of that variable to these various cases. So we were going to say if it's red, if it's blue, if it's green, it would be recognized. Anything other than that, it would be a blank variable, and then it would not be recognized. And that's pretty much it. That's the end of the case, the ESAC, the end of the case. So that was our second example. And we're going to get, of course, as we progress, we're going to get a little bit more sophisticated with the examples that we create. So let's go into the third example. Let's create another one. Okay, so this one has a few more pieces to this script. So in our example 3 here, we have a few echo commands that run at the top that essentially just describe what the purpose of this script is, right? So we just want the user to select an option. So they're going to say, they're going to choose whatever their option is, and it might actually even be better if I were able to do this. And let me see if I can cut this so I can do that and it would cut it. Nope, it did not cut what I wanted it to cut. It cut my shebang line, which that is not what I wanted. So I need to actually be on the line that I want to cut, which would be this line. And we're going to cut that line and then go over here. And then now we're going to paste that line. So there we go. So first it's actually going to say, hey, what's your name? And I'm going to give it my name. And then it's going to echo these options. So it's going to say, select an option. And let's even do this to make it even more customizable, right? We're going to say, hey, name, select an option. And then we're going to give the name their options. And then, say hello, show date, or just quit. And then finally, we're going to enter another prompt for them. So we're going to provide another prompt for the user to say, enter your choice between these options that you have over here. And then their choice between these selections is going to be stored in the choice variable. So this one is storing it in the name variable. This one is storing it in the choice variable. And then we're going to go down here and then we're actually going to enter our case statement. Now, in case the choice that they have given is 1, then we're going to echo a hello to their name because they want us to say hello. In case their choice, the choice that they have is number 2, then we're going to display the date for them. In case the choice that they have is Q, then we're going to just say goodbye and quit, right? And then finally, if they choose anything other than these options, then it's going to say invalid option. And then just to make life a little bit easier, we can just say, please choose another option. There we go. And that's it. And then finally, of course, we have ESAC at the bottom to close the case statement here. So now we are completed with our particular script. We're going to write that out, exit out, and then we are going to run case one more time. And it's going to say, first, what's your name? My name is Hank. It says, hey, Hank, select an option. And I'm going to first do 4. So it's an invalid option. Please choose another option. So we'll go and run it again. And now in this case, so check this out, right? if we wanted to have this keep running, we would actually turn it into a while loop. But in this case, I actually have not done that correctly. So let's actually exit this out and go over here and let's go back into our case script here. And as our option at the very bottom, at our very last option here, instead of saying please choose another option, I'm just going to say invalid option, and then we'll do shutting down to make it simple enough so that the person understands that when they run this and they choose an invalid option, it's actually going to end the script. So now again, if we do 4 and press enter, it says invalid option shutting down. So there we go. So now we're going to do case sh. So what is your name? I'm going to say name is Hank. I want to get the date. So it'll give me the date. And there you go. Voila. We're going to run this one more time. It says, what is your name? I'm going to say Hank, and it's going to say choose option 1, and I'm going to do hello, Hank, right? So you can see how you can create various cases in this particular case. And with essentially with all of the options, you can allow for more choices to be made from the user depending on the functionality of the script. So we actually had a few interaction points in this particular script that first allowed them to enter their name. We stored their name, and then they were given the instructions that they were going to do, and then make a choice. And then once they made their choice, we were able to run the rest of our case. And now, if we wanted to actually do this, we could probably just customize it a little bit more and turn it into a while true so that as long as they provide any of these things, or maybe not even while true, if it's any kind of an invalid option, instead of shutting down, it would just go back to the top of the loop and it would rerun it until they chose one of these options, these 3 options that we have over here, and then the script would continue to process. But we did that actually earlier when we were creating one of our earlier while loops, and so from that you can just recreate that if you wanted to. In the interest of time, I'm not going to recreate it one more time because we've actually done that one time. So I do want you to go review that if you want to learn how to do that, and you can combine that with what we did here, because essentially we actually created one of the pretty much the same exact script that you're looking at, and except this one has just, I think, 1 or 2 more modifications to it. But for the most part, we actually had created the same exact script earlier, and we did the while loop version of it. So that is it for this particular example of our case statement. So let's go and look at another example. Okay, so this example is going to be a little bit more functional, and hopefully this one will actually be able to be used in something that we have done or that we will end up using in the future. So first, we're going to start with our read prompt. All right, so here we go. This is the new example that we got. So we start with a prompt and it says, hey, what is the document? And then, or what is the file? I should say that's probably the better version of this. And we would say, we would given them also an example, which is provide us with the name and the extension, for example, document.pdf, for example. And then we would store the response to this prompt inside of this file variable. And then it's going to say, in case inside of this file there is the .txt, then this is a text file. In case there's .pdf, then this is a PDF file. In case there's .jpg or .png, and the way that you can say or in this particular case, or inside of case statements, the way that you can say or is with this vertical pipe that we have here. So you're going to look at .jpg or .png, or you can even continue to add more variations to this, right? So I could go here and add another one, which, I mean, I guess .gif. So maybe that could be a thing. So if it's a .gif, any of those options, if it's any of those options inside of the file variable that they give us, then we can say that this is an image file. And then over here, finally, we'll say, I don't know the file type. So unknown file type, and the script is now going to exit. So in this particular case statement, what we're going to look at is we're going to analyze the variable that we've been given, and then we want to see if .txt is inside of it, if PDF or JPG or any of these things are inside of it. And if they are, great, we know what to say. If they are not, we just say we don't know the file type. And that is what this case statement is doing. So let's actually save this one, close it out, and then of course run it and see what it does. So what is the file type? And I'll just say image.gif, press enter. This is an image file. Run it again. What is the file type? And I'll say file.txt. This is a text file. So you see, essentially, you'll see how this actually works, right? So portable.pdf, and it's a PDF file. So you can see how the case statement, for the most part, I mean, it's very repetitive. I understand that it's very repetitive. I'm just giving you different use cases because I want you to get this embedded into your brain. I want you to understand exactly what it is that we're accomplishing here and what we're trying to do and what the function of the case statement is. So it essentially just looks at any variable, and then it's going to look to see if any of the options that you've allotted, any of the options that you've declared are inside of that variable. So in case the variable has inside of it .txt or .pdf or .jpg, png, or gif, we have responses to it. In case the variable inside of it has nothing that is inside of these options here, then we're just going to say as a default that this is the final answer. And then from there, we're going to run it. So again, let's actually run that one last time. And instead of providing something else, we'll actually do case.sh. And it says unknown file type .exiting because there is no such thing as .sh in our options. If we wanted it to be, we could add another option and say the asterisk that we had and then .sh and then do that close parentheses and then give the options of echo, this is a shell, right? That's essentially what we could have done to make sure that we cover all of our bases. But for this particular situation, we don't need to, because I just want you to see how to look for extensions, for example, for a file, or to look for portions of a response inside of your variable. So you could technically just do this in different variations. So we could essentially have any given string and then have this piece inside of it and say, it would be error and then have that at the end of it. So if there is error inside of this variable, then we're going to handle that option the way that we want to handle it, right? So you can technically look for anything inside of your variables so long as you create your pattern accordingly. And then from there, you can have your script run a number of options for the commands that you want to run and for essentially how you want to handle the found option that you're looking for, right? So what do you want to do? If that it has been found, what do you want to do, basically? So this is what the case statement does. So I do have, I think I have, no, actually, that's it. That's the last example that I had for you inside of the case statement. So just to kind of wrap it up, just to summarize here. So it provides a readable way to handle multiple conditions. It provides a structured way to handle multiple conditions. And these are our conditions. And essentially, what we're doing is that we're looking inside of this variable for our conditions, and we're looking to see if inside of this variable any of these options exist. So if we refer back to the option where we said, choose option number 1, option number 2, option number 3, or option quit, right? So if we refer back to that, option 1, we were actually looking for the number 1 as their choice. Option 2, we were looking for number 2 as their choice. And option 3, we were actually looking for the letter Q as their choice. So if they provided either 1, 2, or 3, then we, inside of that variable, case would be able to find 1, 2, or 3 because it actually existed inside of the options that we had provided them, right? So if they had given us any one of those actual responses, then we would be able to find what we're supposed to do. And we would say, okay, so their response was 1. So what we're going to do is we're going to interact with it this way. Response was to, response was Q. We're going to interact with it this way. So long as inside of their response, one of our options exists. And if it's not something that is solid this way, if it's not something that is I would say not dynamic, static. If this is a static response that they've given us, which a static response in my eyes is something that can't be molded. So if there was a asterisk in the front or back of it, they could essentially give me anything that had the number 1 in it. So it could say 310, and it still would elicit this particular rule, and then it would, or this particular condition, excuse me, it would elicit that particular condition, and then it would actually do the command that I wanted it to run. So that's basically what it does. So it is a structured and readable way to handle multiple conditions, and these are our conditions that we would state, I would declare. And it's very useful for processing command line arguments, like we did earlier at the very first one, user inputs, which we've done multiple times, and of course various other conditions, as we will go through and create some more examples of case, and then combine it with while loops and for loops and so on and so forth. So that is all I have for you for case statements. And then we're going to move on to the quick little next section that we have, which is for variables and command substitutions. Okay, so now what we need to do is clarify a few things and officially talk about the use of variables and how we can use variables to substitute for commands. So as we've gone through in all of the shell scripts, for the most part, I feel like every single one of the shell scripts that we've created, we've at least used one variable inside of them, in some cases multiple variables. So for the most part, you should be familiar with variables. This is not a new concept for you. To create it for you in just the what is it? Let's say the shell itself inside of our terminal without creating a script. So to just demonstrate this for you, we can go ahead and store the value of hello inside of this greeting variable. Now, when I press enter, now it's actually been stored inside of my environment, and I can just go and do hello or echo greeting, and it'll print hello onto my screen. So this is a very basic use of a variable, okay? And we've done this in multiple cases inside of our scripts, inside of the command line terminal itself, and we can even do it for creating a full-on string, like a full sentence. So if I wanted to do, for example, name equals Alice, which I've done before, so name would equal Alice in this case, and then I want to do echo, and then I want to say my name is, it's already on my screen, so we'll do the squiggly black squiggly braces here, and we'll say my name is name, and then now it's going to print this, and it's going to say my name is Alice. And if I change this to let's say Hank again, and then we'll just save that now, and then I go up and I say my name is name, and I'll print this and I'll say my name is Hank. So in this particular case, what we're doing is we are storing a very basic string inside of the variable. Now, previously in all of my other examples, I would use something like echo my name is, and then I would just do the $ and then name and print it, and it will still work, right? But what happens is that when we get into more advanced scripts, right? So let's go and kind of demonstrate this real quick. So when we get to more advanced scripts, let's say we want to write my name is name, and or we want to generate a username for somebody, but we want to add something to the end of their username. So your username is, and then it would be, let's say, name, but then what we want to do is we want to add at the end of their name a series of numbers. So it would be, let's say, name 123 would be what we want to add to it. If I store the value, or if I refer to my variable in this particular manner, what the system is going to look for is it's going to look for the name123 variable. So it's going to actually look for this full thing. And if I run this, it doesn't exist. Like nothing is actually over there because we don't have something called name123 that's stored in our environment as a variable. So if we wanted to append the 123, if we wanted to concatenate the name variable as well as adding the 123 to it, we would need to separate it by these squiggly little braces. And now we're actually referencing the name variable And now we're able to add the 123 to the end of that variable. And so if I run this now, it says your username is Hank123, or excuse me, I did that incorrectly. I need to put the dollar sign outside of the brace. So now I can actually do this. So that's the correct way to do this. So we would reference the variable and then it would actually reference Hank123. You see that? So the best way, the best practice to do this. And I apologize for just introducing it to you now, but this is the official section for dealing with variables. And earlier I was just trying to show you something real quick just to demonstrate the overall purpose of, the if statement or the while loop, so on and so forth. So the best way to reference a variable from now on to the future is to put the variable inside of these curly braces so that you can then further manipulate the variable. For example, create a username as such. Okay, so let's say Hank's office is in 90210, right? So we're going to say your username is Hank, and then we would do 90210. And that would basically be what their username would be. It would just be their name along with the zip code of where their office is located. And that's how we can make sure that they get a unique username no matter how many Hanks we have in our company, for example. So this is one of the best ways to refer to a string variable. Now, what's going to happen is that a lot of times you also need to substitute the output of a command inside of a variable. So, as an example here, we can say current date, or whatever, current date equals dollar sign, and then put the date command inside of these parentheses. Now, what I've done is that I've actually stored the output of the date command inside of my parentheses. So if I actually type in date, we'll see that we'll get the date onto the screen. So we have taken this command, we've taken this output, excuse me, and we've stored it inside of this variable for further use, for later use. And the way that we do that is by doing the dollar sign, open parentheses, put the command in there, and then close the parentheses. And now I have stored the value of this command, which would be this. I've stored the output of that command inside of my current date variable. So now if I wanted to actually write out a echo command, for example, and we would say today's date is, and go like that, and then of course make our reference as best as we can with our squigglies. So if we did current date and then close that off and then close that, press enter, and then we get today's date is the value of the date. Okay, we can do this in a lot of different instances. So one of the ones that I try to show you is the system info. For example, what I was creating earlier was system info. I would put it right here and I would say uname A, and then that would be the value of the uname A command stored in system info. And so if I wanted to see what that potentially would be, I would run that, and this is the full value of uname A, right? So that's the everything that we can get from the uname command about our specific system's name and the version and yada yada yada. So now we can say, okay, your system's information is, and then we would go and reference our variable by doing system info inside of the squiggly brackets. It's so funny that that's like the technical name, squiggly braces or whatever. So the technical technical name is squiggly braces. So we would now do this, and then it says your system's information is yada yada yada. So this is how you can actually store the output of a command inside of a variable, and we can do this with a bunch of different commands. So you're not limited to just the singular command. So let's actually do some fun work here. So let's go inside of our directory file or directory folder, and we can see that we have a multiple number of txt files inside of this folder. And let's say I have a dozen, okay? Let's say I have a dozen locations or a dozen files inside of that folder, or dozens, let's say hundreds of files inside of that folder, and I have no idea how many they are, and I want to find out how many they are. In the file explorer, typically, when you go inside of a file explorer, it makes it easy for you to see this. So if I went inside of my terabyte volume right here, at the very, very, very bottom right here, I don't know how to zoom in. I wish I knew how to zoom in on Linux. This is one of the biggest things that's bugging me. I was able to do it inside of my Mac OS. I'm able to do it inside of my Windows. I don't know what the shortcut is for me to zoom in to this freaking portion of the window at the very, very bottom right here. But let's say if I just minimize this and I brought this up so that you could at least see this portion right here. So if we look at this portion, it says that there's 37 folders, there's 36 files. So when you're dealing with the GUI, when you're dealing with the graphic user interface, this is not a hard piece of information to find. But a lot of Linux distributions, especially servers, when you're inside of a server, you don't have a GUI, you just have a command line. And you need to know how many files exist in something in a specific location. So this is actually a really useful tool, this series of commands that I'm about to give you. It's actually very useful. So let's say files count will be the name of our variable, and we're going to store inside of that variable the combination of two commands. One of them is ls for list, so you already know what that is. And then we're going to pipe the output of ls, and we're going to include it in the word count. So we're going to count the output of ls, and we're going to count the number of lines that are generated. So that way we can actually see how many files are inside of this particular location. So I'll just do this and I'll store that. Boom. And then what we're going to do is echo the number of files in this directory are, and then we're going to reference our files count variable. Press enter, and it says there are 6. So not crazy, right? It's not a really fancy command in this particular case, but what I can do is I can expand on this and get something that is massive. So I can get the response of a large amount of files. So for example, let's actually look at a location that has a lot of files. So if I list the contents of the var log directory, we can see that we have a bunch of log files. Or not even that, if we went inside of let's say the contents of the Etsy config, I think it's Etsy, is it Etsy config? So let's see, let's look at Etsy, for example. We have Etsy right here. And then we have a bunch of configuration files inside of Etsy. There was one specific location that I knew that there was a lot of log files or a lot of files in general. I think it's actually the var log file usually that is the most populated because the fact that there's so many different logs that are generated. So if I do an ls of the verilog file one more time, and we can see these are our different locations, and then let's go to journal. So let's say ls verilog journal and see what we have in there. And we have this massive thing, so I actually should probably go into it and see if inside of that, what is the name of this? CD6, yada, yada, yada. We're going to go inside of that. And inside of it, it's not that many. Huh. I'm kind of disappointed. I was trying to find a location that has a bunch of files in it, but unfortunately, there isn't much. So maybe it's the bin. Or CD bin. Let's see. Inside of the bin, inside of the binary, we have a bunch of stuff as well, but none of these things have extensions, but there are a lot of stuff inside of this binary folder. So this is probably a good location to do our command as well, to try to find what the number of files are inside of my binary folder. So let's say I'm trying to see how many binary files exist inside of my binary folder. So I can just now do count, and then I'm going to store that inside of this particular variable, which is going to be the ls, and we're going to pipe that into the word count l, and that's going to be our command, and we're going to go echo the number of files or number of binaries, let's say, are, and then we will reference our variable by referencing count like so, and boom, enter 3,701 binaries. Ha! How crazy is that? That's actually a very useful series of commands, because let's say you don't have a GUI, let's say you don't have a graphic user interface, and for whatever reason you need to find out how many binaries there are, or how many files there are, how many logs there are, whatever it is, you need to find out the number of entities, number of assets inside of any given location. You can very simply just do ls and then feed the output of ls into the word count and count the number of lines that are generated, and immediately you get the count of the number of assets or files or documents, whatever, inside of that given given location. So it's a very, very useful number of commands. But the whole idea is here that you can combine several commands inside of those parentheses and then have that be the variable value that you've generated. So let's say that we want to look at the type of, let's see, we can do something like even this. So we can say echo the current directory is, and then I can even do this. I could actually even do this, and I can do that. And then it says the current directory is bin, right? So I can even, without creating the variable first, I can just put inside of my string, inside of my echo string, I can actually put a command and just reference it very similar to what I would with creating the variable. And I could actually put that inside of my echo and it will give me still the output of this command. So echo the name of this or the info of this system is, and then we will go boom, open that up, uname dash A, close that up, boom, the info of the system, right? Clear that up, and we could do echo the name of this host is, and then go like that, uname just by itself, and then close that up, and the name of this host is Linux. So it's very, very useful to be able to store the value, the output of any given command inside of a variable and then be able to reference that variable. So I have one more example for you, and this is another combination of a series of commands. And what we're going to do again is we're going to try to count the number of instances that something shows up. So we're going to go back into our home Kali desktop location, and we're going to go into the directory location, which we know it has multiple text files. So let's say I have hundreds of text files. I have no idea how many there are, and I just want to find out what they are. So we're going to create a variable, and in this case, the variable is going to be, again, the combination of ls, and then there's going to be grep for the .txt extension inside of this. And then we're going to pipe that into word count and the count of lines. And that would be the total series of commands for our result variable. Press enter, and then we're going to say echo number of txt files are, and then boom. Let's reference our result variable here. There we go. Result command not found. Oh, because I used the incorrect syntax. So when you put it inside of parentheses inside of the string, it's actually going to look for a command named result. If you're trying to pull up the variable that you created, you have to use these squigglies. Otherwise, it won't look for a variable. It's going to look for a command called result. So when I do that now, it says the number of text files are 6. So that's very, very important. So that the specificity is very important. So when you're trying to reference a variable, you're going to use these squigglies. And when you're trying to reference a command inside of your string, inside of your echo command, for example, what we did here, this would be referencing the command here. So what I could do here, exactly what I did before, is I could actually do ls, and then I can feed that into grep and do a .txt search and then do wcount_l, and that would be the full command, and I would still get the same result. So if I'm going to use the parentheses, what would end up happening is that I would have to actually put the command or series of commands that I want inside of the parentheses. If I want to reference a variable, I need to put that inside of squiggly lines, the squiggly braces, so to speak. And that's basically it. So that's how we can reference variables, create variables, and that's how we can put the output of commands inside of variables and substitute the command itself for a variable, and then substitute the variable for the command. That's probably the better approach. I'm a little bit dyslexic, if you haven't noticed throughout this series. But that's basically it for our variables and commands. There is one last piece that is an actual official line item inside of my training notes that I want to make sure that I give you. And we've done it so many times, and I haven't specified, I haven't given like a dedicated few minutes for this note. and it's important to understand, but you have seen me do it so many times because we've created so many shells. So a shell is an executable, and what we're going to be doing is we're gonna, in the next section that we're about to go into, we're just gonna start creating shell scripts. And I'm gonna try to do as many useful shell scripts as I can for you. So we're gonna start creating shell scripts. A shell is an executable, meaning there needs to be executable permissions associated with a shell. So for example, we are inside of this directory. So let's go back one. And let's see, we have these shells. All of these things are already executable. But what I'm going to do is I'm just going to create a new one. So we're just going to create a new shell. We're going to put our shebang line at the top. And then we're just going to say echo hello. Okay, this is our entire shell script. Okay, we're done. Now, what I want to do is I want to run my shell, but it's going to say permission denied because I never gave it the executable permission. So new shell, you can see right here that it's this white color. Well, all of the other ones that are actual executables that I can execute are not white. They're this like light green and they're in bold, right? So this new.sh, even though it is technically a shell file, even though inside of it there is the shebang line at the top that says we're going to use a shell interpreter and we actually have a shell command inside of it, it still won't be processed as an executable unless I actually assign the permission to it so that it can become an executable file. And the way that we would do that would be with the chmod. So I always run it as sudo chmod because sometimes you don't know. And I've created all of the files that I have as the root user. So I do need to run it as sudo chmod because everything belongs to the root user. And if you want to change the permissions of the files that belong to a root user, you have to use sudo. If it was just a file that was created by a regular user, you necessarily don't have to use sudo because sudo is referencing only people that are administrators or in the root, the sudoers file. So that's kind of digressing, but I always do sudo chmod in all of my tutorials because I'm always the administrator and all of the files that I create are owned by me as the root user administrator. So I have to use sudo. In a lot of cases, if you're just creating something and you're a regular user and you're not on the sudoers list, you don't have to use sudo. You just go chmod and then you do p plus x, which means you're adding the executable permission to this file. And now if we run it, we can see that it has now turned into the new.sh is actually turned into a shell. And now I can run and then it will say hello to me. So you need to add executable permissions to all of your shell scripts in order for them to execute because by default, the UMask value for most systems does not add the executable permission. So you have to add the executable permission yourself. By default, that's typically what it's like. So you can do it in two ways. The one that I just showed you was the symbolic version. This is what we call the symbolic version, where you say plus X, and then you give it the name of the file that you want to give the executable permission. My way that typically ends up being a little bit faster just when as I type it out is I just do 777. And 777 means there's read-write permissions for everybody that has been assigned to now this specific file, for example. And now that file is going to have executable permission. So we'll do this one more time just so you can see what's going on. So I will do nano and then Mewtwo.sh, kind of reminds me of Mewtwo from Pokemon. And then we will go right here, bin bash, and then we're going to do echo hello again. And that is our script. We're going to close that out, clear it up, ls. We can see that new2.sh is not executable. And just to even make it a little bit easier to analyze that, it's not just because of the color coding. When we look at the permissions, we can see that there's no execute permissions that are attached to anybody. So the person who created it, which is me, I don't even have execute permissions, and neither does the group that I belong to, and neither does anybody else, right? So if I just want to make sure that I have that executable permission, I can just do sudo chmod, and then I can even if you don't want to give it to everybody else. So let's say that we just want to keep the others group right here. We just want to keep them at a level 4 because read has a value of 4, write has a value of 2, execute has a value of 1. So when you add it up, it's 7. I just do 777 because it's super easy and I'm doing it inside of this training series. So for me, it's just like, let me just run it real quick. But technically, I could just do 7, 7, and 4 and it would still turn it into an executable file for me. And then I would do new2.sh and I'm good. And now I can do ls and we can see that new2.sh is also executable in my situation. And now I can go new2.sh and it'll run it and it says hello again. So you have to make your shell files executable. That's basically the whole point that I'm trying to drive home here. So that's how you do it. You just do the chmod command and you do either plus X or you do chmod 77 and then you make sure that you have the executable permission as the owner of the file and then from there you are all good and then you can run your shell scripts. So that's a really big important note. I've done it multiple times already in this section of the training series. I just wanted to take a specific section and assign it to hey, you got to change permissions and you got to make them executable in order for all of your shell scripts to work. So we're about to go into the creation of shell scripts and we're going to create several really useful shell scripts. And I just want you to not have any problems running your shell scripts inside of your computer. So that being said, let us now go into the creation of shell scripts and some really, really cool ones that are super freaking useful. So let's do it.
This training series is sponsored by Hackaholics Anonymous. To get the supporting materials for this series, like the 900-page slideshow, the 200-page notes document, and all of the pre-made shell scripts, consider joining the agent tier of Hackaholics Anonymous. You'll also get monthly Python automations, exclusive content, and direct access to me via Discord. Join Hackaholics Anonymous today.
All right, we have now arrived to our actual script creation session. So everything that you have learned up until this point is about to come together and you're about to learn how to create some very useful scripts. I believe I have a total of 8 scripts that I'm going to create live in front of you. And then from here, what we're going to do, I'm going to first type it all out because instead of explaining line by line, I'm going to type it all out and then I'm going to add comments to every single section of the code so you can kind of see how it all plays out. And then from there, I will explain each piece line by line and we're going to use, essentially a combination of everything that we learned inside of this command line, as well as inside of the lecture series for this training on Linux. And hopefully, this will actually be useful to you in your everyday life, in your personal life, as well as everything that you do when you go into the workplace, the job market. So let us begin on creating our very first shell script. Okay, so if you remember when we were in the section under networking and we were looking at the uncomplicated firewall, the UFW uncomplicated firewall, we had created multiple firewall rules, and then there was a portion where I was trying to delete all of the rules that I had created, but I wasn't able to, or I wanted to delete all of them in bulk in one command. But I wasn't able to do it, and I had to delete them one by one by constantly writing in the sudo UFW delete and then do the number that's associated with the given rule. And that took longer than it should have because especially if you have a lot of rules, right? And you don't want to just repeatedly run commands and just the redundancy of it, the remedial it feels so freaking annoying, okay? When you have to constantly do the same command over and over and over again, especially when you know there's a better way. So in this particular case, that better way is creating this script. And I actually just noticed that I did not add uh, a quotation at the end of this, so that would have been an error right away. So this is our essential command here. This is our script, and it's the basic version of the script. I actually have a more advanced version of this script that I'm going to create right after this one, and it'll essentially do the same thing. It just has a few other elements to it that will verify that we've actually made the right choices, and it will confirm with us that we want to delete it. And then once the rules have been deleted, it'll actually create a log for us to let us know that everything has been deleted, so on and so forth. So this is literally the most basic version of this. And so the first thing that the script is going to do is it's going to run a UFW status numbered command. And then on the screen, we're going to get the set of rules because I recreated some firewall rules for UFW. And so we will have the set of rules on our screen. And then for each one of those rules, there's going to be a number associated with that rule. And then the very next thing that the script is going to say is which one of these rules do you actually want to delete? And then you would have to separate them with a space. So this is the reason why we have this specific section doing the example for us right here. So you would need to separate each number with its space, and then the result of this prompt, so whatever I enter as the prompt or whatever you would enter as the prompt, is going to be stored in the variable choices. And then the for loop is going to start where it says for choice in choices, do sudo UFW delete the individual choice and then finish it off. You may notice that I have started doing this, and we're going to continue to do it this way, where every time we actually refer to any given variable, we're going to put it inside of the squiggly brackets because of the fact that we just want to make, and there's actually going to be one of the scripts that we're going to create where this is actually going to be a very important element of the script. So the reason why we want to get into this habit is that at some point we're going to start modifying these variables, and it's just good for us to get into this specific habit of putting the variable, referring to the variable inside of these squiggly brackets. And then from here, essentially, it's just going to run through the command and it's going to delete everything that we wanted to delete. So I'm going to just run this one time, and then I'm going to delete only one of the rules that we have. So if I actually go sudo UFW status and then numbered, we'll see, oh, I thought I actually had my rules. It seems like I don't even have the rules. So let's do sudo UFW enable, and let's enable it. And let's see if the status will now display. Okay, there we go. There are the rules. So we actually have the rules. So obviously the firewall does need to be active in order for the script to work. So we have four rules here, right? So we have the input rule, so incoming traffic, and then we have these two that are going to allow incoming traffic, and then we have denying incoming traffic. And this specific one is going to be from this IP address or to this IP address on port 22, which is going to be denied. And then this one is going to allow from this IP address and to the, or from this IP address and to this IP address on port 25, which is going to be our SMTP, Simple Mail Transfer Protocol. And this is actually one of the kind of like the public shared IP addresses that Google provides us that we can store in our own location or put in our own resolved domain configuration files, so that when we do a certain number of NS lookup or dig or any of these commands that would actually go send probes out to retrieve IP addresses from different locations, this will be the IP address that will show on our end. That's kind of just some extra information for you. It has nothing to do with this particular exercise or this script that we're creating. I just wanted to kind of run that by you one more time so you know what we're doing here or what these things actually mean. This is just a placeholder IP. It means nothing. These rules essentially mean absolutely nothing. They've just been created for demonstrative purposes, for demonstration. So what I'm going to do is I'm just going to delete this first one. Okay, I just want to run the script and then delete that first rule so that for the second script that we create, we're going to delete the remaining three rules that we have over here. Okay, so we're going to clear the screen. There is our script right here, UFW1SH. We can see if we run a L command that this is not executable. And the first thing that we need to do is just make it executable. So I'm going to clear the screen. I'm going to do sudo chmod plus X, and then I'm going to do the ufw1sh file. And now if we run the lsl, we can see that this is now an executable script. It's an executable file. So that being said, I can actually now run this and it's going to prompt me. So it says, oh, I need to run it as root. I totally forgot my own freaking command here. So we're going to, what am I doing? Clear this out. We need to run it as sudo because I literally forgot my own instructions. So there we go, sudo ufw1, and now it actually ran. You see right here. So this is the output of the UFW status check. So the status is active on UFW. These are the rules. And it says, which one do you want to delete? And I'm just going to say 1 and press enter. And syntax error expected sudo line UFW delete choice. Let's see, what is my syntax error in this particular case on line 15? Let's see. Aha. So this was my syntax error. So this is the mistake I made. You actually have to put a semicolon at the end of your for loop in order for this to work. If you don't put a semicolon, you can put your do on the next line and it would essentially have the same effect. If you're going to include it on the same line, you need to separate this specific piece by having do separated by this semicolon. So I believe this should actually be fine. So let's write it out and test it out. And here we go. Let's try that one more time here. So we're gonna delete 1 and allowing da da da. Do you want to proceed? Yes, I do. And rule has been deleted. So perfect. So that actually worked perfectly fine. So now if I actually do a sudo UFW status numbered, rule number 1 was actually deleted. So if you remember, it does replace by itself. So next time, I guess I should have done rule number 4 so we could still see that the original rules are in place. But if you remember, we had 2 allow rules at the beginning, and the first allow rule was to destination 888 on port 25, and it was to any from any, or so from any location to that, so on and so forth. So we can see that it worked essentially. So the script actually did work, and that was the specific UFW1 script right here. And so the big difference, the syntax error that I had made was on this line right here, which was this specific semicolon was missing right in this location, right after this red choices right here that you see, semicolon was missing. So if you're not going to include the semicolon, the do needs to be on the next line so that the script can actually break it apart as 2 separate commands. In this particular case, I just want to include it on the first line because based on everything that I have learned and all the instructions that I've given you, we have done it this way. So I don't want to start switching it up for you right now and then make life even more confusing. So what we're just going to do is we're going to maintain this particular approach where once we have our header, right after the header, we're going to do the semicolon and then we're going to give the command where we say do, and then we're going to move on to the actual command on the next lines. So that was it for our given basic UFW rule deletion script. So now what we're going to do is we're actually going to save this, and I'll give you 3, 2, 1. If you want to screenshot it, if you want to pause the video to save this, and if not, obviously, if you're a member of Hackaholics Anonymous agents and above, you're going to get the original document that actually has these rules in them or these scripts in them. So you could just copy paste these scripts and use them at your leisure. But if you wanted to type it out yourself, you could pause it here and then type them out and then save them and moving on. Okay, cool. Let us move on to the next one, which will end up being UFW2.sh. We're now going to create a new script for deleting UFW rules. And this one is going to be a little bit more sophisticated. It's still going to be simple. It's just going to be a little bit more sophisticated and it's going to have a couple of extra functionalities. So let's get into that one. Okay, so as you can see, this one is a little bit longer than the other one. We still are doing an advanced, or we're still doing a UFW rule deletion script, but this one, as you can obviously tell, has a few more pieces to it. So obviously it starts out with doing the status numbered command so we can see what the status is and the number of rules that are available with a number associated to them. Then it's going to take the response of this prompt saying, enter the number of the UFW rules that you want to delete, 1 through 5. And we can even make this a little bit easier just so we can kind of make it so that we can actually see the choices in the same line at the very end. So it's going to take and enter the number of the rules that you want to delete, and it's going to store it inside of the choices variable here. And then for loop will begin, and this is going to validate first and foremost. And this is not going to input anything or print anything onto our screen unless the input that we give is invalid. So it's essentially going to check whether or not the choice is actually a positive number. And if it is not a positive number, then it's going to say invalid input, choice is not a valid rule number. And if it's not really a number that's available to any of our rules, it will do the same thing. So if the rule is not, if the rule number that we give it does not exist, or if the rule number that we give it is not a valid integer, then it will prompt us that this is invalid, and then it's going to exit. So we should actually even put that here, that we're going to say exiting at the very end of this so that the user knows. So exiting. So if it is indeed a positive number, or if it is indeed one of the numbers that we have on our rule list, then it's going to prompt us and it's going to say, are you sure you want to delete these rules? And then we are going to provide either a yes or a no. And in this particular case, we are going to provide a yes. So we are going to confirm. If the answer is not yes, okay, so if we say no, I don't want to delete this, then it's going to say deletion canceled and it's going to exit the program. If we do say yes, then it's going to move on to this next segment of code, which is going to essentially process what we did before. So for choice in choices, sudo UFW delete that specific choice. If the response of the system, so if the response of UFW is equal to 0, if it gives us a response of 0, a status of 0, that means it's been completed and everything is all good. Then we're going to get this prompt over here that says it has been deleted successfully. The choice that we want has been deleted successfully. If we don't get a response of 0, which is typically a response of 1, if we get a response of, if anything other than 0, then it's going to say failed to delete that individual choice. And that's pretty much it. That's the end of this specific script. So I'm going to, I mean, for the most part, I explained it pretty well. So if you want to type it out and save it for yourself, you can just go ahead and rewind this by, let's say, 30 seconds a minute or something like that, and then save it and write it out for yourself. If you want these to be hand delivered to you on a silver platter, it is available on the Hackaholics Anonymous Agents and Above membership. So I'm just going to plug that. And you should get used to me plugging that because that's kind of my job in this thing. That's basically all I get out here. So we have this script, right? So we have the script that is not an executable yet. So we do have to get to the chmod plus x ufw2sh so that we actually get an executable script here, which is perfectly done. So now we're going to actually run our UFW2 script here. And so there we go. It starts out the same way, right? It's going to print the rules on our list for us. I want to actually delete 1, 2, and 3. Press enter. Are you sure you want to delete this? Yes, I do. And it says conditional binary operator expected. So here we go. Syntax error near the rule. It says rule choice deleted successfully. Conditional binary operator expected. So now I gotta go troubleshoot this so that we can get an actual functional script in this particular case. So let me go ahead and figure out exactly what happened there. Okay, so we ran another test run. I just wanted to confirm and make sure that it actually worked properly. And here is what was wrong. It was actually another like really simple thing. So there was really nothing. It was kind of something that I just missed as I was typing. So originally, this was what was missing. I was just missing that quote in front of or at the end of this confirm variable right here. So if you can see this, there's this quote here, and then the very next quote is this quote. And then my not equal sign, my conditional operator in this case is inactive. So the conditional operator that I was getting as an error was this not equal to that I did not, the script wasn't reading because I didn't have that quotation right there. So when you actually put that quotation, now the conditional operator, as you can see, has been turned into this green color, meaning that it's actually acting as a conditional operator. When it's sitting inside of the overall quote, which would be this full piece right here, because that's this quotation and then this quotation. When it's sitting inside of this, now it's not even acting as a conditional operator. It's just a part of the string, right? So that's the piece that was originally missing. And I just put that in there. And lo and behold, it worked perfectly. So let's now run it one more time in a live situation so that you can actually see it working. And then we will move on to our next script. All right, so here we go. Sudo ufw2 sh. It ran it. These are our two remaining two rules. I want to delete 1 and 2. Press enter. Are you sure you want to delete them? Yes, I do. Now it's deleting this one. Do you want to delete? Yes. Delete it and moving on. So rule 1 deleted, failed to delete rule number 2. It said it could not find rule number 2, which is interesting. Oh, you know what it is? I think it's because when you actually delete rule number 1, then what happens is this is actually very interesting. So it's going to remove, that's so interesting. It's going to take rule number 2 up one notch. So it's just going to move it literally. It's just going to, that's so interesting. So it's going to remove uh, or move the rule that was originally in the second position. It's going to move into the first position. So there's no longer a rule number 2. It's only a rule number 1. So I actually have to modify this script because there will never actually be a technically in that kind of an environment when we only have those two rules, there will never be two rules. So we can say, that's very, very interesting because now in this particular case, it's not deleting what I wanted to delete. That's a very interesting troubleshooting issue. So I have to try to figure out how to solve that particular troubleshooting issue. Okay, so here is what I believe will be will be the fix to this particular issue that we are having. So the problem was, as you saw, so anytime that you delete something, so for example, if I'm choosing to delete rule 1 and 2, it will first proceed to delete rule number 1, or the previous version of the script would proceed to delete rule number 1. And then if that happens, then rule number 2 moves up a position, and that rule number 2 becomes rule number 1, which means that there's no longer a rule number 2. And in our script, the script is going to be looking for a rule number 2, which means rule number 2 no longer exists, which means the script can't process what it's supposed to do. So what we're going to do is we're going to convert our choices variable, which is what we gathered up here when we got our choices from the user. We're going to convert the choices variable into an array, which is essentially a list. And then we are going to sort that array. So for the choice that is inside of the choices array variable, we are going to echo that choice, and then we are going to sort that choice in reverse order. And that doing that means that if we've chosen 5, or if we've chosen 1, 3, and 5, then what's going to happen is that it's going to first process number 5, which means number 3 will never actually lose its position. Then it's going to process number 3, which means number 1 will never lose its position, and then it'll process number 1. So in this manner, it should now actually work the way that we want it to. And the rest of the script is pretty much the same, except we've just changed the name of our choices variables that was over here, and it's been turned into the choices array. So this, I'm hoping, will actually work the way that we want it to. So I'm going to clear this out. I'm going to add a new rule. So we're going to say deny SSH. And so rule added. So if we do sudo UFW status numbered, we should now have, okay, so there we go. Now we have three rules, okay? So we are going to now delete rules 1, 2, and 3 using our UFW2 shell script. So we're going to do 1, 2, and 3. Are you sure you want to do it? Yes. Yes. Rule deleted, rule deleted. Okay, great. Yes. And yes. Okay, perfect. So that actually worked like a charm. So as you can see, first it asked, are you sure you want to delete the rules? We said yes. And it says, okay, first I'm going to delete the deny 22 TCP, which is this one right here. This is deny 22 TCP. Are you sure you want to do that? Yes, I do. And then it deleted it, the v6 version, which is this one. Then it says rule 3 deleted successfully. And then it's going to say deleting deny 22. Are you trying to delete that? I say yes, and it says rule 2 deleted successfully. And then deny from whatever. Are you sure you want to do that? I said yes, and then rule 1 was deleted successfully. So it's working its way backwards up the list instead of from the top to the bottom. And that would actually save us from this little issue that we had. Because if it deleted number 1 first, then what would happen is that number 2 would become number 1, number 3 would become number 2, and we no longer would have a number 3. And then that would break the whole thing down. So if we start from the bottom up, it would actually be the perfect solution. And this could be the same thing. So if I was 5, 3, and 1, and I had 5 rules here, it would first delete number 5, and then it would delete number 3, and it would delete number 1, which wouldn't mess with the order of these original rules in any way, which would still prove its function to be exactly what we want it to be. And I am so happy that actually worked. I love it when code works and we are able to troubleshoot through things. So that was it. So we have officially, we have two very successful scripts for deleting UFW rules. And actually, so honestly, we need to also modify this one. So UFW1 nano UFW1 SH. We need to actually modify this one as well because this one is going to operate exactly the same way. So what I'm going to do is I'm going to essentially just copy the second portion of what we did in that last script, and I'm just going to bring it over here and I'm going to paste it here because I do want UFW1 to actually work the same way that UFW2 does, which is essentially this piece right here. We need this exact portion to be inside of that other script as well so that it will work in the same manner, which is this whole section right here. So we're going to go here, we're going to paste our clipboard, and that's it. So now we have the official version of this script. Wait, this is, what just happened? Oh no, okay. I see what it did. I always forget that inside of Nano, you can't scroll with your mouse and then assume that the actual position of the cursor has also moved down with you. So what we need to do is we need to actually just delete this whole piece right here so it ends up where we want it to end up. And then from here, we can go ahead and paste the clipboard. And there you go. So convert choices to an array and sort it in reverse order. There we go. For choice and choices, still the same variable. Everything else is going to work exactly the same way. And then it's going to delete the rule. And then we're going to be good. So there we go. So that is the full version of UFW number 1. The very basic one, even though now it's no longer that basic of a script, but it's still a little bit more basic than the other one. And then you already saw what the second rule was going to look like. And you are going to get access to both of those rules inside of the Hackaholics Anonymous agents membership. Okay, this script, as you can see on the screen, is going to be our backup script. Now, there are a lot of different ways that you can do this. There are a lot of different tools that we have covered through the command line instructions as well as the lecture series for backing up. So there is, of course, the creating tape archives, the tar archives, or zip files, or something like that. But then there's also tools like rsync that are actually very, very useful. So in order for this to work, what we need is we need a folder essentially that we want to back up, and then we need the script for is going to create a location the backup is going to be stored, and then from there it's going to also create a log file for us to display what happened during the backup process. And all of that is going to, for me, I'm just going to choose the same location where the backup is going to be stored to also store the backup log file for me. So this is going to be called the backup.sh file. And very similar to everything else, it's going to start with our shebang line. And then I'm going to just start typing it out, and I will start leaving comments so that you can kind of follow along with me. All right, so here we go. Let's break this thing down. This is going to be a good one. This is going to be a very useful one. I can feel it in my bones. All right, so the first one, we're going to prompt the user what directory they want to back up. So they need to provide the full path, as we can kind of see from our example over here, that they need to actually provide whatever the source directory is going to be that they want to back up. And then that's going to be stored inside of the source underscore dir variable. The next one is going to be where do you want to store the backup? And that's going to be inside of the backup underscore dir variable. And of course, they would need to provide the backup location as well. Then the next one is going to be where do you want to log the results? And specifically, I have given as the example backup directory log as the location for them to store the log file. And then that the whatever path they provide, that now this could again be any location. It could be the verilog, the directory that they want to store their log file. It's totally up to the user. I think it's best to actually have that log file be inside of the backup directory itself. And then the value of this prompt is going to be inside of the log file variable that we're going to generate. And then we are going to create a full backup directory variable, which is going to be the backup directory variable / this command that we're providing to the system. Now, this is very, very important because I kept repeating throughout the scripting section that we want to put our variables inside of these squiggly brackets, and this is the reason why. If we're not used to putting the variable inside of squiggly brackets, what's going to happen is that this / is going to be assumed to be a part of this actual variable, which is going to ruin it, and then this piece is also going to be assumed to be a part of that. So the whole thing is just going to become chaotic. So we want it to be separate. So we put it inside of its own squiggly brackets, and then this / is going to be a literal /, and then the result of this command is going to be printed to the end of this particular variable. And I want to copy it and make sure that this specific command is actually going to generate the result that I want to, because I'm not sure if these things are supposed to be capitalized or lowercase. So that piece I want to make sure that runs smoothly. And then what we're going to do is first we're going to have the script create the directory, which is going to be this full backup directory, right? It's going to first create that directory. And then we're going to run the rsync. Now I just caught an error here. So rsync is actually the command that we want to run. And then we want to run it with the append as well as the verbose output so that it just prints it onto the screen, what it's actually doing. And then we're going to run it with the delete, the -- delete option, so that if you run this repeatedly, it will delete it'll essentially sync both of the directories, the source directory and the destination, the source and the backup directory. They're going to be synced, and it will delete anything from the backup directory that no longer exists inside of the source directory, and vice versa. It'll delete anything inside of the source directory. Actually, no, I'm sorry. It's going to only delete the things that are inside of the backup directory that are no longer inside of the source directory. So it's literally going to it's going to sync the destination, the backup directory. It's going to sync it with exactly what the source directory looks like, so it doesn't overlap anything. It's only going to keep exactly the files that are inside of the source directory. And then the output of that is going to be appended to our log file location, and deleting any of the error messages, for example, the jargon that is not necessary, that is irrelevant to what's going on with our entire operation. These double greater than symbols are meant to represent appending instead of if we only had one greater than symbol, which would overwrite this log file every single time that you did it. So essentially, every time that you run this, it's going to append the results of the most recent backup that you ran. It's just going to append it to the end of this log file. So you have a history of all of your backups. And then it's going to actually check for the success message, the success response code from the rsync tool, and it's going to determine if it's a response code of 0, meaning that there were no errors and it completed successfully. It'll print that the backup was completed successfully. If it gives us any other kind of a response, any other response code, then we're going to get a notification that the backup failed, and to check the log file for the details on the failed backup. And that is basically it. I hope I have not made any mistakes in my syntax, but if I have, then we'll come back, and of course we're going to see, fix this, and essentially, hopefully, be able to fix it quickly so that we can actually make it functional. But for the purpose of this exercise, I believe I'm done. So I'm going to close this out. First, I'm going to run the date command because I want to see if it's going to. So it says command not found. Oh, because it's actually doing it as a variable. So I'm going to paste it first. I'm going to delete that. And then I'm going to delete that. Then I'm going to run that. Okay, perfect. So it actually does work the way that we want it to. So that is fine. The date is fine. So now we're going to look at our list of scripts, and we do have the backup shell right here that has not been turned into an executable. So we do need to do the chmod executable to the backup.sh file to actually make it an executable, and there it is. So I'm going to print my working directory because I want to use this as my home base for running the rest of the script. So home Kali desktop is where I'm going to start storing my stuff. And there is a directory on home Kali desktop that actually has contents in it, which is going to be the directory that we're actually going to back up. So we are going to have the pwd here one more time, and then we're going to run sudo, and we're going to run the backup.shell. I don't think you actually need sudo permissions for this, but just in case. So what directory do you want to back up? It's going to be home Kali desktop directory is what I want to back up. And where do you want to store this backup? I'm going to do it in home Kali desktop and backup directory. We'll just do that. Directory. There we go. And where do you want to log the results? Which is going to be home Kali desktop backup directory /log. Enter that. And command not found backup.sh backup failed. So command not found on line 18. So let's see what is wrong with line 18 of our script. Oh, so it's the rsync tool. We actually don't have rsync installed on this. Sudo apt install rsync. It's already at the newest version. So I wonder why it's saying it's not actually working. So why is it not working? So let's see here. Oh, I see. Interesting. It doesn't have the backup dir log directory. I think that's what the issue was. Okay. All right. So that makes sense. Okay. So since that is my issue, what I'm going to have to do is it seems that I actually need to create the or use a different location to actually store the log because I would need to actually create or just put it inside of the shell file for it to actually create our backup location for us. So first, let's see if it's been creating the backup directory. It has. It's created the backup directory, and we need to uh, delete this thing because this is useless now. Permission denied, cancel. So I need to actually delete it as a sudo user. So let's go into our shell real quick and exit this out. So let me do some house cleaning real quick. So this is actually interesting. So as we're going through our uh, troubleshooting here, it actually seems to have created the backup. So it actually has created the backup, which is an odd thing. And it created the log file for me as well. And the log has been stored inside of my backup directory. It just did not create a log directory, which is the issue, it seems. And if I go and go up and look at my other one, which is the dbackup directory, same thing with this one. It actually has completed the back. In this case, there is no contents inside of this one. So I think this one actually failed completely. But so what we need to do is we need to troubleshoot our script so that it creates a backup log directory so that it can store the log inside of the backup log directory. And then from there, we will be able to hopefully run this smoothly. So we have removed all of our backup directory. So let me just also remove the backup right here. Cool. And there it is. Okay, so there's the whole thing. So let's now go and fix the script. And from what I gather, I think this is actually the biggest issue right here is that there was just no log file directory. So I'm just going to create a log file directory, which is going to be this specific location. So after the backup directory has been created, it's going to create the log file directory, and then the rest of the script should run fine. So that's what our current state of the system looks like. So from here, we're just going to just run it and see how the whole thing works out. So fingers crossed, here we go. Hmm. Okay. I gotta figure out what's going on. I'm having another issue here. So I gotta figure out what this is. Let's do some troubleshooting. I will come back to you with some answers here. Okay, so this one, we were actually very close on the first iteration of the script. That's why we actually did get a backup that was created on the first run around. The issue was in the most recent run of the script, I actually added the making of the directory for the log file, and it's not supposed to be a directory. It's actually just supposed to be the location of where the log file is supposed to go. So we're supposed to remove this portion, and then I think specifically my error was in the redirecting of the standard output and standard errors. The redirecting of those errors, I believe I had an issue with it because specifically what I had here was I had a dollar sign that was before this ampersand right here. So if we zoom back into our view, the dollar sign over here that you can see on the bottom right, hopefully you can see this piece right here, that dollar sign is not supposed to be there. It's just supposed to be two greater than symbol, ampersand, and then the number one. And I removed the make directory command to create the log file directory because it's not supposed to be a log uh, uh, directory. It's just supposed to be the file that's going to go inside of that given backup directory. So in that case, I think everything from here should actually work because I think the biggest error was actually with this piece right here that was giving us the issue. So we are going to run it one more time. And I am crossing my fingers that this thing will actually run smoothly. So let's check it out. Oh, my goodness. I messed this up so badly because the dyslexia kicked in. This is supposed to be home Cali. It's not supposed to be Cali home. and I completely messed that up. And let me guess, I have another backup dir that was just created. So we need to recursively remove the backup dir. And you guys, when I tell you that dyslexia is actually a real thing, I hope I'm not like reaffirming that, but it feels like it's becoming an issue here. So backup.sh one more time. Let's try this one more time. Hooray! It completed. Literally, the only error that I had inside of the actual file, inside of the shell, was with this piece right here. I had a dollar sign in front of this ampersand, and that was the biggest part. That's literally actually the only error that I had, and I was trying to fix it by adding a new directory because I thought I was missing. I was supposed to create a directory for this, but in actuality, we weren't supposed to do that. We were just supposed to remove the dollar sign between that ampersand. So far, every script that I've created, literally there was like one letter or one character that was out of place, and that was the reason why the script was failing. But if we run this, now we actually have a backup folder. So if we go into the backup folder, we actually see that we have a copy of the directory folder, which the contents are right here. And if I wanted to ls the directory for you as well, so if I wanted to ls the contents of home, Kali, desktop directory for you, you would see that the contents of that directory are exactly the same thing as this, which means that our sync, our backup actually worked perfectly. And now we have a full backup shell script. What did I just do? How's this? What? I thought I had a backup shell script. Oh, because I'm in the wrong location. Sorry, my bad. So if we go into this, now we have a backup shell script. There we go. So this is officially our backup shell script, and it works magnificently well. And I'm super excited about this one. So we can close this out and we can move on to our next script. Okay, so now this script, and I think like we're going to create a couple of really simple scripts. They're not as lengthy as the ones that we've done so far, but these are going to be very useful. They're very powerful scripts, and these are the types of scripts that you can essentially schedule as a cron tab type of a job that will run, let's say once a day or once a week or however frequently you would want it to. And these ones are, or this very next one at the very least, is more relevant to the system itself. And then the one after that, we're actually going to create a user creation script. And then we're going to do a couple of other ones that are kind of system related and yeah, I mean, yeah, that's pretty much it. So it's like I have, I think, 4 or 5 system related ones for you, and then one that is more for the system administrator, meaning you and the job that you have to do, which is creating a user and just doing that process fairly automatically. So this one is going to be our health check. So we'll call it the health check shell file, and it's going to start as always with the shebang line at the top. And I'm gonna start working on it, and we'll review it when I'm done typing. Okay, that's pretty much it. Fairly simple script. And you can probably tell from the very top 4 lines, we have just a series of echo commands. The first one is just going to be the title of the script. The next one is going to print the date that you're going to run it from. It's going to print the uptime, so how long the system has been up. It's going to the next 2 commands. So this one is going to just say that we're going to check the memory, and then we're going to run the free command in a human readable format so that we will get the memory usage using the free command. And then we're going to do the disk usage, not the desk usage. Goodness gracious. We're going to look at the disk usage, and we're going to run the disk file system in a human readable format. And then we're going to check for the top 5 CPU processes. And we're using that with the PS command to check for the processes. We're going to look at everything. And the output we want is the PID, the COM, and then the memory usage, and then the CPU usage. So the E stands for everything, O stands for the output, and then when you use the output flag, you actually have to declare which columns you want to be printed, which are going to be these columns. So the PID, the comment, the memory, and then the CPU in that specific order. And then we're going to sort the output by the CPU, and it's going to be from the, I want to say descending. I think it's going to go from the descending order, so the highest to the lowest. And then the head dash N is going to take the top 6 lines from this output that we're going to get from the PS command. And the first line is going to be the actual headers that we're going to get from PS. And then the next 5 lines are going to be the actual processes that are going to be running on the computer. So we are going to close this thing out, and we're going to do a chmod plus executable on our health check shell. And now we should have an executable health check, and we do. So let us actually run the health check shell. And it worked beautifully. So we have system health check, date, uptime, memory usage, and then we have the, let me see, disk usage. Where's disk usage? I just saw disk usage. And then we have at the bottom right here, top 5 CPU processes. So I do want to make this a little bit more easier on the eyes. So the one thing that I'm going to do is I'm going to separate these elements here with just some more equal signs here, just to make it a little bit more user friendly. So instead of it being like that, we will actually just do this kind of an output. So we have some user friendliness with this, so we can know where the separations come in, right? So we can know where each one of these portions are separated. And really, I think even the better way to do this would be to do this in all caps. So memory usage like that, and then go here and do this in caps as well, disk usage, and then we will do this portion as well, where it's going to be the top 5 CPU processes, and we will do 1, 2, 3, 4. Let's do that, and then we're going to come here and we'll do 4. There we go. So we have that, and that should be a nice separator in this case. And so let's run this one more time, and let's see if we can find them easier. So there we go, top 5 CPU processes. That's cool. We have disk usage. That's much easier to find as well. And we have memory usage. So that's definitely much more user-friendly. And I actually like that a lot. If we wanted to, make it even more user-friendly, we would actually echo a couple of blank lines here to make it even more user-friendly. But for the most part, this thing is actually running very smoothly. So I don't need to do anything else. I just feel like it would be a little bit more user friendly if I did do something else. So if I go ahead and just echo some empty spaces, you know what I'm saying? So we'll do an empty space over there, and then we will do an empty space above this one, and then we will do an empty space above this one. And last time we're going to run this before we move on to the next script. And there we go. So now we have that empty space, and it makes it a little bit easier to see these different segments. And there we go. That's our health check script. Super easy script. Very, very easy script to write. And you can actually add whatever other command that you want into this. So if you wanted to use the disk usage command, you could do that. This one is disk usage by itself, but we're actually running the df command, the disk file system. But you can use the du command, and you would get the output for that with the du command. Top 5 CPU is currently being run with PS. You can essentially add anything that you want to a script like this to make your output very, very nicely done. And then what you can do, even if you wanted to, so this is kind of another way that you can do this, just to make life a little bit easier, right? Is you could do this, and then we can do check.txt, and then it won't print onto the screen, but now I have the check.txt file that's over here, and I can go into the check.txt file, and I can see everything inside of the check.txt file, which makes it easier to manage for later on if you wanted to do it that way. So this is, I would say, one of the more important scripts actually that we've created, because it's doing a very nice amount of work for you, especially if you start adding even more commands to it then it'll start running even more commands, and then you'll just get an output. And then uh, if you learn how to forward these things to your email using the SMTP protocol for mail transfer, and then actually email that to yourself, then you are off to the races. I created something like that using Python. It's beyond my depth right now to do it with Bash scripting, but I actually did create something like that was monitoring my disk resources and the utilities that were being used, and it would email me anytime that the usage of my disk was beyond a certain threshold, and I would declare how much the threshold would be. So, if it gets past, let's say 15%, or let's say it uses up 80% and it's left over 15%, or if it uses up 85%, sorry, if it uses up 85% and it's left 15%, or if it uses 80% and it's left 20%, it would just email me and I say that your disk is reaching capacity, and then I would have to go and do troubleshooting, which it's never happened, but this is another one of those ways that you can kind of keep the health of your system in check, just to make sure that everything is all good. And in case something does happen, you actually get a notification. That will be beyond the scope of what we're doing here. But it's not that hard, especially when you go and use a tool like GPT, for example, to teach you how to do these things. The format of shell scripting, as you can see here, this is one of the ones that it kind of puts not the backup, excuse me. Well, even this right here, honestly, but the format of the health check. What we see over here is really not a complicated script. It's just that what it's doing is it's running individual commands on the system. So it's as if you were typing these commands inside of your terminal, but in this particular case, you're just writing the commands inside the shell script, and then it's being run for you. And the big piece here is this shebang line at the very, very top that declares that everything inside of this document is now command that I'm putting inside of my terminal. So treat everything inside of this document as if it's a command I'm putting inside of my terminal. And when you run it, every single one of these things are being treated as a terminal input. And so when you do free.h or df or du or ps, or if you did the ps auxiliary aux, or any of the other commands, if we ran rsync or any of the ones that you see right there in our previous scripts right here, right? So when you see this right here, for example, the make directory command, that's as if you are inputting make directory into your terminal, and then it's just going to create that directory for you. The rsync is as if you're running the rsync command, and it's going to do that for you. So most of these things are actual commands that you would put into your terminal. It's just these if else statements and the creation of variables, as you see right here. These are the elements that make a script reusable so that you can interact with the script and run it in multiple use case scenarios. But for the most part, it's fairly intuitive. And I think if you practice this, you can get a lot done, and you will get really good at this. And then it will make your life easier for your own life and your day to day. And then it will make life easier when you go into any kind of a job that requires you to create shell scripts for a Linux environment or a Mac OS environment, because the languages are very similar. But if you wanted to, I mean, it's not that much of a stretch to actually do this for a Windows environment either. So scripting in general has a lot of these similarities, where you have if else statements, you have the creation of variables, you have for loops, while loops, and so on and so forth. So yeah, that's all I'm gonna say about that. So we are now going to move into our next script, which is going to be another really useful script for you, which is the user creation script. And that's, again, another one of those really good ones that you can recycle and reuse multiple times, and it will make your life super, super easy. So let's go and create the user creation script. All right, so here we go. We're going to call this one users.sh. We'll just call it that. And then it starts with the shebang to make it officially a script. And so here we go. Okay, so if you watched the section for our user creation in the command line, you should recognize all of these commands that we've ran. So the user add command with the actual username, and what we did with dash is that we created a home for them as well, a home location, a home directory. The dash S is us assigning their shell. Dash G with a capital G is us assigning them to any supplementary groups, and in this particular case, we're assuming that the groups have already been created. I don't have any extra groups created, so I actually have to create a couple of groups real quick in order for this script to just run. But apart from that, the rest of the script is fairly simple to understand. This portion right here, because we want a secure way to generate the password, and we don't want to hard code any kind of password in our script, because if somebody is sniffing our traffic, if someone is doing a man in the middle type of an attack and they were going to look at our log files, or there's a lot of different ways that they can actually read the contents of what we do inside of these interactions if we use a plain text type of a password entry. So what we're going to do is we're going to use the actual password tool, which when we input our commands inside of the password tool, it's going to have it encrypted. First of all, it's going to be hidden from plain view, so nobody's going to see it on the terminal, but then the password itself is going to be encrypted. So that's the big piece that we're doing, and this part requires interaction. So once you run this and the username and everything's been created, you are going to be notified after this piece that username has been added to system and to the groups. You're going to be notified to enter a password, and then you're going to be notified to verify the password. And then once that's done, you will get a final notification that the username has been created successfully. So real quick, I'm going to write this out, and then I'm going to create a couple of groups here. So we'll do marketing, and we'll do a what do we do? Developers. Let's do developers, and we'll do marketing. So if we do this and then we just go a cat of the Etsy group file, we'll see that we have the marketing and the developers groups that have been created. So we're all good here. So now what we need to do is do a chmod of this and make our users shell executable, and we need to run it with sudo commands because this is a shell that requires sudo. So we run it and it says enter the username, and we will do Bill Nye and enter the groups for Bill Nye, and we'll be marketing, comma, and then developers. Username Bill Nye has been added to the system and to the groups, so the new password will be password, retype, updated successfully. User Bill 9 has been created successfully. That's it. How simple was that? How easy is that to interact with? And now check this out. We now can go ahead and do a ls of the home folder, and we see that we have a Bill 9 location. We can go ahead and do a sudo get ent of the group marketing. And okay, I need to spell marketing correctly. There we go. So we can see, oh, you know what? Bill is not added to that group. That's very interesting. So let's see if we can, let's see what we can do here. I need to verify that we've actually added Bill to the marketing group. That's very important. Okay, so here's the issue. When we add a new user, if we have not signified what their primary group is going to be first, they're not going to get a primary group, and they're going to have their primary group be their own username. And so in order for this to work, we actually have to designate a primary group, and then we can add them to other supplementary groups. Apart from this, I feel like that was the only thing that was missing. So we prompted the user to enter the new users. So prompt, let's do prompt admin. So this is actually not confusing here. So we're going to prompt the admin to enter the new usernames, and then enter the primary group, and then to enter the groups for the user to be added to, and then we're going to run it. I think that should be fine. I already deleted the user that we have, and we still have our original groups. I'm going to create one more group, and we'll just call it the users group, and then from there we'll run it. And I think we should be okay. Excuse me. All right, so here we go. enter username. We are going to do Jill9 this time around. Users will be her primary group, and then we will have marketing and developers be the other groups. And password is going to be good, and password is going to be good. Everything is all good. So here we go. Here's the moment of truth, and we still don't have the addition. So what if we do get ent group users? Callie is here. Get ent group users like that, and users is empty. So the group users actually works, but the group marketing is empty. Sudo get ent group developers, and that is also empty. And I'm officially annoyed. Okay, so let's try to figure out what's going on here. Okay, I think the issue was that the get entry command from what we were doing actually wasn't bringing the entries where we had. So there are multiple ways that you can check what groups a certain user belongs to. And I have tried this in a variety of different examples right now. I was just trying to troubleshoot and figure out why it wasn't displaying it. And I believe I know why it wasn't displaying it because get entry, and this has happened in a variety of different exercises that I've ran as well. So it's not just this particular exercise, but sometimes get entry doesn't give us the entries that we're actually looking for. And we have to use a different command to verify whether or not a specific user has been added to a specific group. So what I'm going to do is I'm going to run this script one more time. And then we're going to create the new user one more time. And we will do Brad Pitt will be our new user. Primary group for Brad Pitt is going to be the users group. The marketing, let's make sure that we spell this, marketing and developers groups are going to be his supplementary groups, and password will be his password. And there we go. Okay, so user has been created successfully. So here's what we need to do. We're just going to do groups, and then we're going to do Brad Pitt. And there we go. So he's actually, oh, he's part of the users. He's part of the root users as well. I wasn't even aware that he was part of the root users as well. But okay, so we've seen that he's actually been added to the users group. So that means that the primary group is actually fine. So we actually do have the primary group that works. So what we need to troubleshoot right now is why the supplementary group is not working. And I believe I know why. So what I did to try to fix this is that instead of putting everything inside of the same user add command, I created a user mod command over here, and I added Brad Pitt to the primary group, and then I appended him to the supplementary group. So what I'm going to do is that I'm actually going to separate this into two different commands right here, and we're going to use the same user mod command in this case. And what we're going to do is add the user mod for this particular user. It's going to be done on multiple situations. So we'll do username, and he's going to be modified to, and we can see right here that the command itself is not reading what it's supposed to be doing. So I can tell. So literally just from right there, you can see that that's not actually reading the flag the way that it's supposed to, I think. So what I'm going to do is I'm going to run this one more time. I'm going to make sure that it actually works. Hopefully it does work. If it doesn't work, then I will come and remove this A, because the flag is to actually do a capital G to add them to their supplementary groups. But if that doesn't work, then we are going to come and remove that A. And then from there, we are going to run it one more time and see how that entire environment works. So let's do this real quick and remove Brad Pitt completely. And let's make sure that he is out of here. And he seems to be out of here. So let's make sure, yeah. So he's not here at all. So let's run the users shell one more time, and we will do Joe Smith, and users will be his primary, developers and marketing will be the secondary, password, password, and everything is all good. So here we go, sudo groups, and we are going to check for Joe Smith's group, and he's inside users and he's inside of roots. But if we do get ENT group marketing, he's not inside of that group. So I believe it's because it's actually not reading this AG the way that we want it to read. So I'm going to run this one more time. And oh my gosh, let's try this again. Group Del, what's his name? John Smith, I think it was. What was the new user that we just created? Joe Smith. Okay, so sudo group del Joe Smith, and then sudo user del R Joe Smith, and it should be fine. Okay, yeah, he's out of there. So here we go. Users.sh. And at this point, after this, I am out of ideas. So for the most part, we're going to have to manually add the guy to his supplementary groups. If this doesn't work, I have to move on to the next script. But I think I think we would have to manually add him to the supplementary groups because I'm at the end of my wits here. So what other user? We'll do Hank, of course. Hank. We want to add Hank. We want him to be inside the users. We want him to be in developers and marketing and password and password. And here we go. Groups Hank. And he's inside users root. And I bet you, he is not inside marketing, which is pissing me off so much. Okay, so check this out. Okay, watch this. If I do sudo user mod and AG and I do developers, marketing, and I do Hank. Okay. And then we do groups Hank, we'll see that he's inside of those groups. This is the thing that I'm like, okay, why isn't this working inside of a shell script? This is the piece that is officially like kind of pissing me off right now. I'm like, why isn't this working? There's nothing about these commands that I have done that are not uh I just don't get it. I just don't get it. I don't know why it's not running it the way that it's supposed to. Maybe it's because there were no spaces or something. Like, should we have spaces? Like, I don't know. I don't, unfortunately, it is currently 1:30 a.m. And I am not able to keep troubleshooting this one particular script. So I will give you an assignment here. If you can figure this out, if you can figure out what's going on over here, I will give you access to our supporters Discord. And we will add you, and you'll be one of the few people that gets added to the supporters Discord without actually being a paid member. And that's my gift to you. So if you can figure this out somehow, I will personally add you to the supporters Discord of Hackaholics Anonymous. So that being said, I do have to move on to the next script. But you did see, the thing is the command did work. It's just for whatever reason that freaking script is not running the command the way that we want it to, and it's kind of pissing me off. But whatever, we're moving on. Okay, so we are now moving on to our log cleanup script. So this script, as the name implies, is going to clean up logs, meaning it's going to delete logs that are older than a certain age. This is very similar to what the rotation or the rotate tool does. But in this case, we are now going to just create a manual script that will essentially just check for the age of something. And then if it's older than a certain age, it is going to delete it for us. So I'm already a little bit ahead of the game here because while I was waiting for the last video to export, I just wrote this script out. And this is also another very simple script. So we have two read commands here. And the read commands create a prompt that says enter the path of the directory of the logs, which in a lot of cases is the var log directory. And then it's going to be stored inside of the log dir variable. And then there's the maximum age of the files, which are going to be in days. So for example, 30 would be 30 days. And this is going to be the days to keep. Meaning after this variable is done, so after 30 days, essentially, it's going to delete it. If it's younger than 30 days, it's going to keep it. So it's going to keep everything that's 30 days or younger, and in 30 days and older, they're going to be deleted. The old logs are going to be found using a find command. So we're going to, put the dollar sign and the open parentheses to imply that this whole thing is going to be a command that will be stored inside of this variable. And then we're just going to write this entire command. And so you should be familiar with this. So the find command requires a location to search, which is going to be the log directory in this case. We're looking for the file type, and then we're looking for a name that ends with log. So anything that ends with the .log extension. And then we have the last parameter, which is the m time. So this is the maximum time, meaning that anything that will be plus this time, right? So 30. So anything that will be over 30 is going to be the amount of time that we are going to use as our main determining factor to determine these things are old, right? So if it's older than 30, then it's too old for us in this case, and then we are going to delete it. So what's going to happen here is we're going to check to see if the value of the old logs is existent. So if we actually have old logs here, and then we are going to actually clean up the logs. So in this case, it says if the old logs, meaning this, if this returns any kind of a result, if we actually have any kind of a result inside of that variable, then we are going to run this command right here. So first it's going to obviously print that we're going to clean up the old files that are longer than 30 days. And then we're going to actually run the full command, which is going to be find inside of the log directory, the type of file, all of this is exactly the same. And then this last piece, which means we want to execute the remove command of the file. And then these are just placeholders to ensure that it is completed. So you do need a placeholder when you're combining at the very end of the find command, and you want to execute a command, especially on the file that you want. So we are going to execute on that file that we have found here. We're going to execute this remove command. And then these last pieces are the placeholders. I don't know why they're there. As I was studying to create these scripts and to execute a remove command, I learned that we need to have these placeholders. So to find out exactly why they're there, I'm actually curious. You know what? Instead of being the guy that kind of phones it home, I'm going to find out exactly why we have those placeholders at the end of that. So give me one quick second. Let's find it out. Okay, the squigglies, the empty squigglies, are placeholders for the current file that find has actually found for us. When find command finds a file that matches that criteria, an example, what we've done here, the placeholder is replaced with the name of that file. So in this case, this placeholder, this empty placeholder, is taking the place of the file that we have found, and then it's going to be worked with that execution. So with this execute command, when we actually use this execute command, it requires something as the placeholder to execute that remove command on. Now, the backslash and the semicolon indicate the end of the command to be executed by the execute command. So this is saying that this is the end of the official command. So in this case, when we actually run through this full thing, we have to find inside of the log directory, which we already know. We're looking for the type of file. We're looking for anything that ends with .log. We're looking for the limit of the search to be modified more than 30 days ago. So the modification time was more than, that's what the plus sign represents. The modification time was more than 30 days ago. And then we are going to execute, and this whole thing is a part of the execute command, meaning these two squigglies are the placeholders that will be whatever was found with this is going to be, that's what's going to kind of fill in there. And then the remove command is going to be enforced upon that. And then these two are the end of the execution command, the execute command. And that's what those specific placeholders stand for. Now I can actually rest easy and make sure that to kind of rest assured that you already know what that actually stands for. So if it does find anything, it is going to delete it for us. If it doesn't find anything, it's just going to say that no files older than 30 days were found. So we are going to save this file. We're going to execute it. We're going to add an execution or execute permission on it. And there we go. And so let's do this. So sudo, and then we're going to do clean logs, I think is what it was called. Boom, enter the path of the directory. I will do verilog. and maximum number, let's say 30. Cleaning up files older than 30 days, cleanup completed. So there you go. We have officially cleaned up files older than 30 days on our computer. How amazing is that? So let's see. Let's run that one more time and we'll do clean logs sh again, and I will do verilog again, and I will say 180 days. Do I have anything older than no files are older than 180 days? So there you go. So, but, I mean, technically, if anything older than 30 days was wiped, there should be nothing older than 30 days left, right? So that's kind of the whole command here. So if we do verilog again, and if I run 31 days, there should be nothing older than 31 days because everything older than 31 days was officially deleted from my log directory. So that script actually works perfectly, and we can now move on to our next script, which is going to be the service status monitoring. So we're going to monitor the status of services on our computer. Okay, so the service status monitoring, as the name implies, is going to monitor the status of the services that we have, and it's going to be using it with the systemctl tool. And then it's essentially going to tell us whether or not a service is active, running, or if it's not running really, and if it needs to restart, and if it needs to be starting. So that's essentially what we're trying to do in this particular case. It's really something that is more for a production environment because I don't really have very many services that I need to restart or do whatever I need to, or not restart. I don't have any services on this because it's a live boot of Kali Linux. There are no services other than the ones that I'm actually using to record this training series. So apart from that, I don't have anything else that I need to monitor to make sure that it's still running. So this is usually for an environment that has a lot of services that are very crucial for the environment to be up and running. And so it'll check for the status of it. And if it's good, or if it's not up and it needs to be restarted, systemctl will start that service. So that's basically the whole purpose of this here. So you can use this command or this script to check to see if any given service is up and running. And if it's not running, then the service will be automatically started for you. And if it is running, then you'll just get a status check and it'll say that it's running. So service check will be the name of our script here. And we are going to write it, and I will come back to you when it's done. Okay, so here's what this script is essentially going to do for us, okay? First, we're going to enter the name of the service that we want to monitor. You can also name list a series of services, for example, as long as they're separated by commas, just to make it a little bit simpler. Now, what's going to happen is that we're going to use the internal field separator, which is essentially, in this case, declared to be the comma. So it's going to take every comma, and anything that is separated by commas are going to be turned into an array. So for example, this would be the response to this. For example, somebody would say, I want to monitor Nginx, MySQL, and SSH. So this, as a result of this command right here, would be turned into this, which is a list. This, we call this a list inside of Python. So this is very similar to a list, and each one of these is going to be treated as a separate item, and it's going to be pulled from the services variable that we have over here, and we are going to store it again inside of the services variable for further processing in this case. Once we have taken the value of this variable and turned it into an array, which is a list that looks like this specific variable version is going to treat it as an expanded list. So this @ symbol right here inside of these square brackets is going to turn this variable that we have that's been stored here, is going to turn it into an expanded list so that each item would be treated separately. And then the command is actually going to activate, which means that if systemctl is active, meaning if the system itself is actually active, the service itself inside of systemctl, if it's active, check it in the quietly in the background so that you don't print a crazy thing onto the screen. Then let me know that the system is actually running, the service is running. If the service is not active, so if the service is active, just let me know that it's running. Else, if it's not active, let me know that it's not running and then restart it for me. And it's going to start the service. So simple script. This is kind of the most complicated portion that we haven't really talked about. I did not talk about arrays, so I do apologize for that. But an array is essentially a list that has been created so that each item here is treated as a separate item inside of this list, and then it will go through this processing very similar to the iteration. So when you're trying to iterate through a series of items in shell scripting, we call that an array. In Python, we call it a list. So if you're at all familiar with Python, you should be familiar with what lists are. And then in that regard, you would go ahead and understand the rest of this portion. So this whole thing, the field separator is also something that's, if you've at all been familiar to any kind of coding, you would understand. If you're not familiar with it, the field separator could be a comma, it could be a colon, it could be a space. You would just need to declare it as such using the IFS tool or the IFS module. And you would say that use the internal field separator, declare what you want it to be, and then read the value of this thing and turn it into a list for me. Okay. This portion is a little bit confusing, so I understand the backwards portion of it is a little bit confusing. And so I actually, my apologies, this actually translates to this, and then this is fed into this piece right here, which will be read into an array. Okay. So sorry about that. Dyslexia, my bad. So this variable is being treated as this. So the contents of this prompt are going to be treated as this, and they're going to be fed into this command right here. And then everything inside of this will be separated by that comma. So we're using that comma separator. So this is what that variable would look like. We're going to use these comma separators as the positions where we will split each one of these items into its own separate item. So it looks like this inside of a list. And once it's in that format, it's ready for processing inside of our for loop right here. And then this at portion right here will treat each one of these as an expandable variable so that you can interact with it by itself and expand on it by itself. So it will treat each one of those as its own entity, and then you will be able to run this specific check on it to see if it's active. If it is active, great. If not, we're going to restart it. And that's basically it. In this particular case, I got to figure out what services I have that are running so I can actually run this command so I can show you what we can do. Because I know that apart from what I'm actually using for this recording, I'm pretty sure there are other services that are running. So I'm going to check what I have that are running. And then from there, I will run this to show you what it looks like when it actually works. So here we go. Okay, so we did a list of systemctl so that it will list our units for us so that we know what is actually running. And so these are the services that are running on my computer right now. So what I can do, I will do the, let's say the cron service. We will use this as our example just to see the status. And obviously it's active and it's running and it's regular background program processing, so on and so forth. So for that, I mean, it should be fine, but we're just gonna run it through our script anyway, just to make sure that the script is working the way that it's supposed to. First and foremost, we need to make sure that we change the script that we just created into an executable. So we need to create the service check. We need to turn that into an executable. And then what I'm going to do is I'm going to actually run the service check shell as our command. And so now we have the thing that we want to check on. So the service that we want to monitor is going to be cron service, and it says cron service is running. What a big surprise. But it worked, right? So let's do this actually and check the other script. So let's say we have multiple units, right? So we have cron service and then we're going to do dbus service as well. So I'm going to copy this selection as well. And so I'm going to run our script one more time, and then we're going to do cron.service, and then we're going to paste in dbus.service. So now we have two values that are separated by a comma, and both of them are running. So we know now that the field separator command is also working, and the script in total is now fully working. And we have created yet another useful script that hopefully you'll actually take advantage of. So now we can actually move on to the next one. I think this is actually our last one. So this is going to be our disk usage alert script. So we're going to create an alert script that will notify us when the disk usage has passed a certain threshold. And this is actually something that I mentioned a few scripts ago where I had created in Python. So we're going to create a version of it inside of Shell where we would get a notification when the disk usage has passed a certain threshold. So let's do it. All right, so the disk usage alert is going to be using one of our friendly commands here, which is the df, so the disk file system command that we've used actually in another script. I think 2 or 3 scripts ago, we used the disk file system command df. So we're going to essentially just create one that is specific just for the disk usage. Oh, the df command is what we did for the system check, the system status monitoring. That's the script that we used it in. So we're going to do disk usage.shell, and we are going to type it out, and I'll explain it. This one should be I think this one should be kind of a quick one. Okay, so this is our disk usage alert. So our threshold is 90. So we're saying if it is above 90, you need to do these series of actions. That's essentially what that threshold means. The usage variable is being filled with a disk file system command, and the disk file system is checking the root directory, and then we're piping the output of this into the awk command, which helps us search for something. And NR2 is going to search for the second field, technically, or the second column, excuse, the second row, my bad. So it's going to check for the second row, and the first row is usually the headers, which is like, it just tells us which each one of these things actually represent, right? It's the header columns, the names of the columns of the data. And then the G substitutes all of the percentages, the percentage signs that you see with a blank space, because we're technically looking for 90 and we're not putting 90%. So we're looking for 90. So if the value is greater than 90, and then don't worry about the percentage, right? So we're just replacing the percentage sign with an empty space to just make sure that it actually works with this integer that we have here. And then what we're going to do is search for the 5th column. Now, when you look at the output of the disk file system, for example, this is what it looks like. So when you look at the output of the disk file system command, this is the 1st column, 2nd column, 3rd column, 4th column, 5th column. So the 5th column is the actual percentage that gives us the amount of usage of our disk file system. So we're printing, or we're accessing the 5th column. We're going to remove that percentage so that it will actually match whatever this number is over here. And then we're going to look at the second row, which is, as you can see here, the second row. So this would be the first row at the top. The second row is where the actual data that we're concerned with is stored. So in this regard, this would be the full command that we're using awk to search for, or search with, excuse me. And then we're looking inside of the output of the disk file system command, and all of that is being stored inside of usage. So essentially usage is just going to pull the value of that 5th column to just make sure it's not higher than 90, right? And this is where the if statement comes in. The if statement says if usage is greater than the threshold that we have, then first of all, print onto my screen that the disk usage is above threshold, currently at yada yada yada. Then echo this exact command to my mail, my mail tool right here, which is going to send me a letter, send me an email saying that the disk usage, this is so annoying, honestly. Let me actually zoom out a little bit. That might be easier. So if we zoom out a little bit, hopefully you can still see this a little bit clearly. So the mail tool is going to send me something, and this is going to be the alert that's going to be inside of my subject line, and it's going to be sent to this email address that I have over here. And then this will be the body of the email, which says this usage is about. So, and that's it. That's like, it's not a complex email or anything, but it's going to echo this string, pipe that echo value, which is going to be the output, right? So the echo command is going to output something. We're going to pipe that value into our mail tool, and that's going to send with this specific title to this email address, and that's about it. Now, the mail tool is something that I want to make sure that you understand as well, so that if you need to set it up, you do set it up so that it can actually run for you. So let's kind of zoom in on this a little bit more to get back to where we were previously. And then from here, from here we can save it. Let's make sure that's all good. Save it. And then exit it out. Let me make sure that it actually saved, because that would be a pain in the butt if it didn't save. Okay, cool. It did save, so we're all good. So we're going to clear that out. We will do a chmod plus X, and then we're going to do the, I totally forgot the name of the script right now. Disk usage. Goodness gracious. Disk usage.sh. Very good. So that's executable now. So let me just try to make sure that you understand the mail tool and how to set that up real quick. Okay, to send an email using the mail command, you need to actually have a mail server that's configured on your system. In the version of Linux that I'm running, which is a Debian-based system like Ubuntu or Kali Linux, we use mail utils. And then you do sudo apt install mail utils, and it'll actually install it for you. If you're going to be using any kind of a Red Hat based system like CentOS or Red Hat Enterprise Linux, then you would use yum to install MailX. Once you have your tool installed, you need to actually configure it. So during the installation, you'll be prompted to configure the mail server. You will set up the system mail name, usually, which is your actual domain name, and then select the appropriate configuration options that would be best for you. You can also get a much more detailed breakdown of this using any of these AI tools. This is beyond the scope of what is covered inside Linux Plus. So as long as you know what it is, you can do it for your own self when you are trying to develop these scripts for either work or for yourself. Then you just test the configuration by writing exactly what we just saw right here. It's really this simple to actually use the mail tool, which is actually so freaking good. If you wanted to use something, for example, like Gmail. So if you want to send something to external domains like Gmail, you may need to configure additional settings like the SMTP server. And this can involve more complex configurations. It might require additional packages like SSMTP or postfix. So as an example, this is what it will look like, and it would just send it to admin@example.com. The configuration for Gmail is the part that I would be most interested for you to learn how to do. Usually, to send something out to Gmail, it's not that big of a deal, but if you're going to use the POP10 or SMTP configuration in addition to Gmail's configurations, you do need to do something on the Gmail end, on the end of the Gmail server, so that you can actually do that. You can use Gmail to send out your emails if you don't have something internally for your own email domain name. So if you don't have your own email address that is at your own domain name like this, and you want to use your Gmail address to send out an email to your own Gmail address, then you would need to use the POP10 server or the SMTP server from Gmail. You can get that information from your Gmail settings, which is not really difficult to locate. You just need to know where you're looking. And then once you have that information, you can go ahead and set up your configurations for the mail utils or MailX, depending on which one you're going to use, so that you can actually send out something like this tool that we did right here. So this is the config. This is the actual uh, the notification script itself. This will work because I actually have verified it with the AI assistants that I have. I use typically multiple AI assistants to make sure that the code that I'm writing does make sense. And usually when I'm missing like a little quotation or some kind of a semicolon or something, the AI is the one that catches it. And it's like, this is why you're having the error that you're having. So that's the big reason why I use them. I try to write all of the code myself because I actually want to learn the code. I don't want to just constantly rely on the AI to do the code for me. And then when I am running into a wall and I need something to be explained to me, I'll use the AI to explain it to me. So I know for a fact that this is going to work. It's just that you need to have the mail tool configured. This is not going to come pre-configured inside of your Linux operating system if you've just downloaded it and installed it. So you need to make sure that you have the mail utilities that are installed and properly configured, depending on if you're using your own SMTP from your own domain name email address, or if you're going to use something like Gmail or Yahoo to configure to send out the email. And then, of course, you can receive email from any email without doing any kind of configuration. It's the sending of the email that's important to do. So if you want to mail it, this would be your subject line. That's the disk usage alert. And then you saw that we added the email address at the very end of it. This would end up being the body of the email, and that's basically it. And then this is where the bulk of the heavy lifting is being done by using the disk file system tool and then using awk to search in the results to pull from the second row, remove the percentage sign so that it actually matches this integer, and then pull the fifth value, the fifth column, because that's where the percentage is actually being held. And that is it for this particular script. And that actually is it for the entirety of our scripts and even the entirety of this training series. We're officially wrapped with the command line tools and the command line scripting and all that stuff for the Linux Plus training series. So I really hope that you found this training series useful. It has been quite the experience for me to go through this. This took me much longer and a lot more time and energy and effort that I thought it would take, but it is actually very satisfying to sit here right now and to be able to tell you that we're officially done with this training series. Overall, I think it's going to probably end up being 20 hours worth of material after all the edits are done and everything is pieced together. And I think you're going to get a lot of value out of it. Going through it was literally like one of the greatest experiences that I've gone through with all of my experience in IT and content creation. So I've had this channel for a little bit under a year now. And to be able to sit here and tell you that this has been the biggest challenge in content creation because it took months to prepare and then it took several weeks, probably actually a month to record everything because it was a lot of content, especially if you go through the lecture portion and then you see there was like over 900 slides inside of the lecture presentation. And then, of course, we had, I don't know how many hours the practical command line portion is going to be, but it's definitely going to end up being two separate videos because the maximum upload time on YouTube is 12 hours. So hopefully, if you've stuck it out this far and you're actually listening to me talk right now, hopefully you had a great experience going through this because it was a great experience to create this content for you. And I hope you got a lot of value from it. And if you want more stuff like this, definitely make sure to check out the channel and search through the content of the channel. Definitely like, subscribe, and turn on that notification bell. And of course, drop a comment if you have any questions about this training series. There is probably some things that were missed in all of the massive amounts of data that I've sent you. So if there's something that isn't making sense, drop a comment. I'll definitely research it for you and I'll give you an answer in the comments. And if it's a big enough question, then I'll create a video in response to your comment to make sure that you get everything that you need to get the most out of this training series. That being said, there's also the Hackaholics Anonymous membership community. And if you want the slideshow and the document, that the supporting document with all of the scripts in it and all of the notes and everything else that's available, those two assets are literally over $500 if you try to go get it from CompTIA directly. So those are available to cybersecurity or cyber agents, which are inside of the Hackaholics Anonymous membership community. It's basically the second tier of the Hackaholics Anonymous membership community. So from that tier and up, you will get access to those documents as well as the slideshow and the notes and everything like that. And of course, you'll get access to me and the Discord channel and exclusive content and Python automations that I release monthly and other exclusive content that's being released. So there's a lot of stuff that is available to the Hackaholics Anonymous membership community. So definitely check that out if you haven't checked that out already. And I do love to see the community grow on YouTube as well as on Discord and everything else that we have. So I'm kind of just rambling on now. So love, peace, and chicken grease. If no one else loves you, Hank loves you. I hope you found value out of this training series, and I look forward to seeing you in the next one. Talk to you later.
This training series is sponsored by Hackaholics Anonymous. To get the supporting materials for this series, like the 900-page slideshow, the 200-page notes document, and all of the pre-made shell scripts, consider joining the agent tier of Hackaholics Anonymous. You'll also get monthly Python automations, exclusive content, and direct access to me via Discord. Join Hackaholics Anonymous today.